Okay, so we have about a minute and some change left. So first of all, again, I just want to welcome everybody coming here, and also members of the Industry Advisory Board, anybody else in attendance, general public in attendance, obviously the students here. Welcome everybody. We're about to get started, and you'll see 7 presentations today. These teams have been working very hard on these projects, and also you get a chance to see what they've been able to create. Again, feel free to ask questions. You have your evaluation forms in virtual format, right? As well as the students. Don't forget to go ahead and open up Moodle and all, and fill out your evaluations form as the teams present. And yeah, so we'll be getting started pretty soon. I want to apologize for not getting a chance to have it breakfast and lunch, kind of without that physical format and all. This is the best that we got here with Zoom and all, but it'd be nice everybody and whatnot, but this is what we got here. So, but I think this is going to be good. So with that, we're very close to getting started. Team lead for lawnmower. Make sure you have all your teammates unmuted, and we're about to get started in a few seconds here. And so let me go ahead and introduce the team. We can go ahead and kick this thing off. So the first team we're going to see is Team Lawnmower, and their project is called Mower with R instead of an ER. And so I'll go ahead and kick it off to them and go ahead and present. Oh, wait, Anna, you're not. Audio is not coming through. Make sure your microphone's on. Do a test on the microphone. Do a test speaker and microphone to make sure.
It says she's unmuted.
Maybe a microphone issue. Go ahead. Yeah, on the microphone icon, do a test speaker microphone and see if it's working. Shouldn't be the case. Let's see.
Hello.
There. Oh, there you go. You were talking, and then I hit mute to unmute, and then anyway, please go ahead.
Sorry about that. Good afternoon, everyone. We are Team Lawnmower. Our project title is Mower. My name is Anna Weeks, and my teammates will introduce themselves.
I am Marcus Castile.
I'm Joshua Mendoza.
I'm Matthew Green.
I'm Jordan Edgell. So real quickly, here is an outline of what we'll be discussing today. We'll be starting off with the problem and solution, talking about the features of our project, then as well as a demonstration, talking about our security and our future plans. So mowing isn't really easy for everyone unless it's a hobby for you. It's more so for us, just like a repetitive task that takes up a good 2 or 3 hours, depending on how much grass you have to cut. And on top of that, during the summer, it gets really hot, especially down here, and it makes it even more of a laborsome task. And on top of all that, for those who might have physical limitations, it's even more difficult or just not really an ideal thing for them to do. And let's face it, hiring someone to do it on a recurring basis is expensive. It's not necessarily affordable for all of us. So we sought out a solution, and we decided to come up with this project called Mower. And it's an affordable automated mowing system that allows users to easily configure a recurring mower schedule through a web application. Now, before we get into the features, we do want to preface with how COVID-19 has affected us in our scope of our project. So due to the campus closures and extended shipping times on a lot of hardware pieces that we would need, we had to cancel all of our hardware stories and focus on more of a proof of concept using Bobots.
All right, so for the features, we really separated these features into 2 parts, the front end and the back end. So for the front end part, some of the main things that we focused on that we actually did accomplish was we made it a system to where users can create an account and users can actually log into their personalized accounts. We did that using DynamoDB, which I'll explain more so once I explain the back end. But also we did, which was really a good thing, we made it to where you can calibrate the mower directly from the app or the web app, which is really good because this actually moved away from what our original idea was. Our original idea and thought process was that someone would have to actually mow physically for the mower to calibrate and actually map the path inside of its memory. But doing some tinkering and actually changes, we actually moved away from that idea. And now we came up with it to where now anyone with a smartphone, laptop, or anything like that can actually just calibrate directly from the app, which we really want to emphasize, which is great. We also have an emergency stop button on the web app for the mower, which is really good just in case you want to actually stop the mower right then and there. And we also made it to where users can edit their profile info, name, address, things of this nature, and it will be saved right in and there. And then to move on towards the back end, our whole project is really built with AWS. It actually is AWS. And so our backend code runs through AWS, our HTML, and, our front end, code, and all of our code runs through AWS Lambda. And for those who don't know what Lambda is essentially an instance of all of our code. So the traditional way of, running a website would be to have a server and you have your files on that server and, that's how it is. The server is always running. What AWS Lambda does is we have our files in AWS Lambda, but anytime someone wants to hit our endpoint, to the website, AWS Lambda will spin up an instance of all of our code and then present them with a website. And this is really good because, it's really nice. It's really good. And so then all of our endpoints are managed by AWS API Gateway. We also use Lambda Authorizer for request security. Just, that's our security. Anna's going to talk about more about that in a little bit. We use DynamoDB, was used for our user and session data, again, to store people's, account information and things of that nature. And AWS SQS was used to handle more messages. And you can think of this more as a queue. And this was used to calibrate our more. So when we get button presses from the web app and things of that nature, it goes through AWS SQS and it gets to our more. And so now I'm going to pass it off to Marcus, so he can go. Oh, excuse me. Before I do that, I want to talk about the tools you use. So again, as I said before, our Amazon Web Services, yes, that's basically where our app is built. And, that was one of the main things that we use. We also use Trello, which, was standard for this project. Everyone used Trello. GitHub, which was what we use for our check code management and things of that nature. Postman, for those who don't know what Postman is, Postman lets us test our endpoints and things of that nature to where we can actually hit an endpoint and then get what the request would send back, in a real live service. And so this is really good to actually test out our endpoints and see what we're hoping and making sure we're getting back what we want. And Cypress.io was used for the front end, and that was used for the front end testing to make sure that everything worked the exact way we wanted it to work. And now I'll be passing it out to Marcus for the demo of our more.
All right, so if you look at the screen here, this is our general login page. This is what a user would see when they first visit our web application. And so if we start off by entering a valid username, such as Joshua, but we put in the incorrect password, once we click login, you'll see that they receive a message saying that their credentials were invalid, and we ask them to try to log in again. So if we put in the correct password this time, and then we click login, it'll go fetch their profile information, and it'll load up the home page. So our home page, as you can see, is a card-based style, and it shows the mower status, the mower actions the user can take on the mower, and the mower battery. We weren't able to fully implement the status and battery cards, but we did get the mower actions implemented, which we will show you in a moment. At the top right, you can see the user's profile picture, as well as us telling them hello. And if you click the downward chevron, you can see a link to the user profile page, as well as something that allows the user to sign out. So if we click on the user profile link, it takes us to the profile page.
Right. We wanted users to be in control of their profile, so we have displayed their information in the user information card to the left there. Jordan's going to go ahead and edit it, but you can see currently we have data already in these spots for first name and last name and email and phone number. Jordan's going to go ahead and edit in that first name and the last name, and we're going to go ahead and save. And this is actually saving it to the database right now in real time. So you can see there, the name is now updated to Jordan's name as he's just edited. Also on our profile page, we wanted to show off configured mowers that users might want to learn and know about. the whole goal here is for users to have multiple mowers of their own. And we also wanted to display a help page just for any useful links or phone numbers or videos that we want to show off for that week. So next we're going to go ahead and show off our sign out functionality. There we go, a successful sign out. And this kind of segues into creating a new account. Jordan's going to go ahead and spoof some information real quick in these fields. And gonna go ahead and make an account for Marcus Castile Jr. And after we go ahead and click the create your mower account button, it's gonna actually automatically log us in once we're validated that all of our information is legal. All right, so now that we're back, we've logged in again for this new profile using the default profile picture there. We're gonna go ahead and show off and explain more our actions and what they do. Marcus Castile is gonna be doing this.
So if you look, our first mower action button is our stop mower button, which is in red. And as Matt was explaining earlier, this is meant as an emergency stop. So if your mower is running, going down its scheduled path, you may want to stop it if something's in the way or if it's making too much noise. You can have that emergency stop button right there. Underneath that, we have our change schedule button. So if a user was to click that, they can then select the date and time that they want their mower to run for the next time. So if we was to select May 18th at say 1 p.m. Once we select that and click save, that then sends a message to that user's mower saying, hey, don't run again until this specified date and time. Underneath that, we have our run mower button, and that tells the user's mower to run the recorded path right now. And then lastly, we have our calibrate mower button. And so when you click that, it expands the calibration section of our mower actions. This presents the user with a D-pad that allows them to move the mower forward, right, left, or back. And they can also stop the mower. As you click on these buttons, they become highlighted. And as you click them, it actually makes a request to our endpoint and API gateway, which if you are authorized, triggers our Lambda code, which posts to a queue. And that queue is actually being polled every few milliseconds by the user's mower. So due to the limitations of actually showing this off on Zoom, we've actually pre-recorded a video for you all to view of us calibrating a mower.
Right, so thank you, Marcus. Here we're gonna go ahead and show off our Bobot moving in action and responding in real time to the actions that we place by clicking the D-pad. You can see like as I click forward, as I click right, and then forward again, the mower responds almost immediately. And it's gonna go forward again, and then we're gonna click the stop mower showing off our emergency stop functionality. So as I click in calibration mode, the mower is gonna go ahead and reverse the order of the actions and return back home. Because the whole idea is for users to be able to place down their mower, calibrate it, and then it would go ahead and return back home hands-free. For the purpose of this demo, what you see here now is it actually running the previously recorded calibrated mower run. There you go. And at the end of a run, it will always just return back home to its original position. Because like I said, the goal is for users to not really have to interact with it all that much. So moving the mower like this in real time definitely calls for some security measures. And Anna Weeks is here to cover our efforts in this feature.
Thank
We
you.
have some questions real quick if you have time for that before you
Sure.
continue. So what is your impression of the DynamoDB? Are there any gotchas involved with that you discovered?
I think we'll actually let Marcus handle this real quick.
Okay.
He's able to.
I didn't find any gotchas. I actually found it very easy to utilize using the Boto 3 library for Python. We decided to go with it because it's real easy to integrate into Lambda functions and set different triggers for it. But
Super seamless with the entire Amazon suite.
Okay. We also have what influenced the choice of using Lambda and static web pages?
So the main choice for Lambda is that it's super cheap. I think serverless isn't really the future. Serverless is here now. I think most websites, unless they're very RAM intensive, should be serverless because it drives the cost way down. And in terms of a static website, you're only returning one file, but by utilizing technologies like React.js, it's not really static because React itself is in itself so dynamic and reactive. Is the name.
Yeah.
Okay. What are some challenges you encountered with developing with Lambda?
So we definitely had a couple issues just with learning Amazon's configurations. I don't want to like shout out another team, but there were some teams that had trouble with pricing issues. And as long as you learn how to work Amazon's configurations, and as long as you try to dig deep and kind of research a little bit about what how you want to configure your Lambdas and how you want to configure the entire Amazon suite, you can drive costs down. That was something that we spoke about a lot because it's our own money at this point.
Fair enough. So you mentioned saving to the database in real time. Is there any kind of data validation that's performed?
Any kind of data validation? We could like match their validation against a regex pattern, but we don't do that at this time, no.
All right, and then let's see, is the calibrate how you program the mowers pattern for mowing?
Yes, right now that is the functionality.
All right, cool. Please continue.
Thank you. So due to the physical danger that a rogue lawnmower could potentially cause, we made sure to place a special emphasis on cybersecurity during our development. I've had multiple opportunities to work in the cybersecurity industry already, and I use this experience to lead my team's efforts in making sure our mower is secure. So social engineering continues to be one of the most dangerous attack vectors in cybersecurity. We see it all the time. In order to mediate this, we've incorporated social engineering training into our product. On our homepage, as you saw earlier in the demonstration, we have a place where users are strongly encouraged to educate themselves on the dangers of phishing. This includes watching a video published by Phishing 101 as an introduction to phishing awareness and prevention. It also includes completing a quiz by Jigsaw on identifying phishing attempts. And I actually took the quiz and it's really good. It's really comprehensive and it touches on all the red flags that are usually present in a phishing attack. Additionally, our login page is totally secure. When the user submits their credentials through the login page, they're encrypted using a SHA-2 hash in order to be processed. This would prevent something like a sniffing attack by not sending any plain text passwords or usernames over a network. Next, we've created a software lifecycle management plan. All our software will be updated or patched when security weaknesses become known, and the new software is pushed out to all of our devices automatically, and this is in order to keep up with a constantly evolving threat landscape. We've also created a blacklist of malicious IP addresses to prevent unwanted contact. Any communication the mower receives will be scanned to ensure the sender's IP is not in a list of already known malicious IP addresses. This list is coming from a source focused on Internet of Things devices and is updated twice a day to include newfound malicious IPs. We'll also be storing our network logs. So all the network activity that occurs on the mower is actively stored and can be easily accessed through a few simple commands. It's important that these logs are accessible in case of a security incident, and we don't want a security incident, but just in case it happens, we have these logs that are there and accessible so that we can analyze them and the damage can be totally remediated. Last, we've installed malware protection on our mower. So the Pi itself is equipped with an open source virus scanner created by ClamAV and a malware checker by the Rootkit Hunter project, which are both open source projects. It's worth noting here actually that the majority of the data that is stored and processed in relation to our mower project is that it's all stored on the devices that the user is using to communicate with the mower itself. So on their laptops and their phones and through their apps. So our mower itself is only really equipped with a basic security system, but that's in addition to all the security events and protections that the user already has on their devices. Now we'll go back to Marcus to tell you about our access token feature.
So when a user first logs into our web application, if their credentials are valid, we generate an access token for them to use, and we save that access token to our database associated with their specified username. So after that, once they're logged in, every request that they make, such as stopping the mower, changing the schedule, or calibrating it, they have to then present that access token along with the specified username. And if that username is not the one associated with the access token, or they present an access token that doesn't exist, of course, that gets ran through our Lambda authorizer, and that request gets denied.
All right, so finally, we want to touch on the future plans. So obviously, our kind of like the most immediate plan that we would have would be implementing a 3D printed mower model with working sensors and cameras. And then as for the UI, we'd want to give it an overall improvement in design, taking into account any possible user feedback, and then implement all the info cards that we had mentioned that we were unable to implement due to not having a physical model, such as the status, the battery, and then a user's ability to configure each of their own physical mower devices. And with that, this concludes our presentation. Thank you guys for your time. If there's any more questions, we'll be happy to take them.
Yes, we have some questions coming in. Thank y'all. So does the mower have the ability to signal back to the user?
The mower can post back to the queue. We just don't put that user feedback on the screen at this moment.
I feel like that would go on the status bar.
Yeah.
All right. We also have how easy is it to modify your mower, your mower proof of concept here to be a personal gardener, that someone can maintain the routine issues of a garden such that, you know, a garden that would be the size of, say, a small yard.
Yeah. So this whole system's definitely very like cookie cutter, able to be like upped and placed in a different like robot. So that's what we're kind of going for here, because we had hardware limitations. I could easily see that being placed with just the right kind of hardware and a little bit of tweaks.
All right, cool. How would the mower know its position? Does it use GPS, RTK?
Yeah, we had a lot of discussions about this in the beginning. I think Matt and Marcus could talk on this.
So ideally what we want to do is have a gyroscope and use rotary encoders so that it knows how far it's traveled and its direction, so it will know if it's off its axis. And that's how we would monitor position ideally. Right now, it doesn't really do that just because we couldn't really implement that fully. But ideally, we'll use a gyroscope and some rotary encoders on the wheels.
All right. Any other questions by anybody?
Good questions.
Yeah, very much so. Very much. Definitely things you probably didn't think of, but yeah, you know, there's a lot of potential, I think, you know, to continue on with this and all that.
Yeah.
You know. Okay. Does the calibration process involve the mower being controlled over every piece of the yard, or just the edges of the yard?
So me and Marcus, while we were kind of setting up the calibration feature, we had a discussion about, because our initial plan was having like a cookie cutter plot of land. So we were thinking about implementing a like math function, I guess that you'd call it, where you'd make a perfect square somehow, and then that perfect square would end up being cut. But what we initially ended up implementing is that it just follows the path specifically. So it is just following the set calibrated path. So you would have to mow it completely, calibrating it.
Yeah, but since we do have it following the exact path, it would be pretty simple to have you like go along the borders of the lawn, say like just the length and the width, and then from there it could calculate the total area it needs to mow and follow a path such as going up, turning, going, and coming back down in a row style cut.
Mm-hmm.
Nice. So can you briefly talk about what additional functionality you had planned that COVID-19 interfered with?
So much.
Yeah, pretty much everything physical.
Yeah, honestly, we very much intended to have a blade portion that would actually we would have videos of it cutting grass, and we had joked about how they wouldn't want an actual mower with a blade running in Tech Point, but we had thought about having just the blade portion being able to be taken off, so you could tinker with it, you could edit the mower. These are all pretty much every hardware story got impacted, sadly.
Right.
Did you look at any commercial modes that exist, and how does your project compare to the functionality in these?
The commercial mowers are, oh, Matt, go ahead.
Well, I was gonna say commercial mowers are really random. What they do, if I remember correctly, what they do is they give you basically a playpen, basically for your mower. you set it around the edges of your grass and it just mows. And it is really random because it knows what the boundaries are. So if it hits a boundary, it'll probably turn around in a certain angle and then just go back the other way in a straight line until it hits another boundary and do things of nature. Whereas ours, you can actually again calibrate from going to where its charging station is, right to your lawn, mowing, and then returning, and like you can put it on a cycle, things of this nature. So it's not just for one just going in a random direction. You can actually plot it, and that's what's different about ours.
And we also, to add on to it, we kind of wanted to have, I guess, multiple mowers too was another idea we had talked about. And then also
It's
going
like
back to and also going back to like a lower price range too, if you were just wanting to get one. Because I know a lot of the ones that are already out there are pretty expensive from what I saw.
So I have a question for me. You may have covered this and all, but just to be clear, do you have a safety feature built into where, let's say, a kid or a dog or something like runs across, not only would it stop, but like actually kill the mower, like turn off the blade, everything else? Do you have features like that in place?
So that was kind of what, if I'm remembering correctly, that's kind of also a hardware thing because we needed sensors to actually detect something in front of the mower. That's why that stop mower function is there, because we also intended to have cameras so you can actually plug in and actually watch and see if there is anything in front. But the sensors would have been able to stop immediately, call that stop function and kill the mower plus the blade. We just didn't get a chance.
Yes. We were also thinking about having a hard stop on the mower itself in some place so that if you need, you can rush over and hard stop it like via a button on the mower.
And also having some barriers in front of the blades to where it'd be kind of difficult to actually cause any harm.
Right.
All right, cool. Let's wait a little bit longer, give a chance for some more questions to come in. It is, disappointing with COVID and all, everything that had to be cut. And I think y'all, you did the best of what you could. Now it's just disappointing that it happened, in the first place.
Yes.
The full vision wasn't able to be realized.
Yeah.
Right. So I guess while we're waiting now, so talk a little bit about how it was. Speaking of COVID, how was it working on this project in a virtual environment, like being collaborating when you can't be next to a person, when you can't pair program, I mean, you can, but not in the same way. How was the changes there between your other classes where you could meet in person?
Right. Good question. Thank you. We definitely immediately recognize how like difficult it is to like meet. We were at the time we were all working, so we were also working virtually from home too. So it's like a definite interest in balancing schedules, which you would think would be easier, but it just wasn't. And that's okay. We did a lot of pair coding, many meetings between us, a lot of Zoom use, thankfully. And we were also, actually, I'm just going to leave the floor for everyone else to talk if they'd like to. I don't want to take it over.
It was definitely a learning curve. It got better. First, even while we were all still together in Ruston, it was a little bit difficult. Things just weren't getting done as fast as we wanted. So when we actually had to all go home and with COVID happening, we were already kind of on the train of like, we need to get ourselves together. What we're doing isn't working. So definitely communication was the number one thing, saying, hey, we should meet up. And today, like, we need to get this done. Here's a list of what needs to get done. Trello was amazing with that. It was very easy to keep track of what was happening and who was in charge of what. So I'd say communication was probably the best tool that we had.
It was difficult to do anything with the robot at all because only one
hardware-wise.
Hardware-wise, because instead of 5 people all looking at it, it can't be in multiple locations. So it's one person looking at it. So like it was like we had a servo break, and it's like, what's going on with the servo? And so you got to replace the servo, and it's just like everything's just amplified, I guess, all the difficulty.
We actually ended up making like multiple lawnmowers, Colin. So this is ours here at our house. Any more questions?
Here we go. What was, and this will be the last question due to time, what was the frequency and type of connection from the user phone to robot?
What was the frequency and
So
type
the type of communication between the two, how's that working?
That was the queue,
Oh, so-
right, Marcus?
Oh, like the
Yeah.
robot pulling the queue. Yeah.
Yeah,
Right.
so like going through the whole thing, when you press the button, that makes a request to our endpoint and API gateway, in which the request then goes through the Lambda authorizer, and if it lets it through, it goes to our Lambda function that takes in and validates the request again, like the format of the message, and then after that, it'll post it to the queue. And so the mower runs on multiple different threads. And so the mower, when it's always polling for messages. And so when it polls and it sees a message that says, hey, you need to enter calibration mode, it'll then enter calibration mode. And from that point on, once it's in calibration mode, it'll say, oh, I can take other commands like move forward, go left, go right. And so then it polls, and then it does an action, so that way, like, that's how we got it to, by using different threads, that's how we got the latency to be very, very, very low. Like the latency got down to some milliseconds.
I'm gonna have to cut you off right there due to
sorry.
time. I apologize.
No, you're good.
Okay, so thank y'all very much.
Thank you.
Thank you. Thank you, guys.
All right, let's go ahead and have our next team unmute and go ahead and start sharing the screen, and I'll go ahead and introduce. So our next team is Jazz with their project CS Wherever. So the floor is yours.
All right. Good afternoon, everybody. We are Team Jazz, and our project is called CS Wherever. My name is Justin Garrett.
Kalikova.
They're muted. Hold on. There you go.
Dan Park.
Christian Thibodeau.
Zachary Phillips.
All right, so the way we're going to break this presentation down is we're going to kind of go over a broad overview of what our project is, and then we'll go into detail about the different technologies that we used, and then we'll go into testing and security, and we'll then go over more detailed portions of our project, and then we'll leave you guys with a live demonstration. So to start off with what our project is, it came about as the result of some research that our faculty advisor / client, Dr. Jacques, has been currently conducting. And she has been trying to determine what the best possible online learning tool would be like for someone who wants to teach themselves about computer science concepts. Because according to her research, about 50% of all high school students don't have access to computer science education in their schools. So naturally, if you don't have access to it there, you kind of have to teach yourself. And through investigating different pre-existing online learning tools, she kind of discovered that they weren't satisfactory. So that's where our project comes in. So our project is actually a prototype for an online learning environment that will teach computer science concepts through the use of the Java programming language. And the concepts that students would learn are similar to an advanced placement computer science course that they would take. And there are three main components to our project. On the home screen, whenever you log in and everything, in the top left-hand corner, you would have an input window, which will allow users to input Java code. And in the top right-hand corner, we have a visualizer window that whenever input code has been compiled and ran, you get a visual representation of any variables that you may have inside of your code. And then our output window is in the bottom left-hand corner, which will display the proper output for the code after it has been compiled. moving on. And now I'm going to hand the presentation over to Asiya, and she's going to talk about the different technologies that we used.
Hi, so let's talk about technologies that we use while developing this project. First, our project currently resides on TechExplore supercomputer cluster at Louisiana Tech University, and we got a permission from its administrators, Dr. Draws, and a PhD student at Louisiana Tech, Christopher Smith. And the reason we chose to reside our project on the cluster is because we needed much more powerful computers rather than our laptops to develop this project. And also it will be residing on the cluster for further development and utilization. Next, we use Docker containers. Docker container is a containerizing platform that packages an application and all its dependencies and makes it easier to run seamlessly and effortlessly. So we used Docker containers to provide reproducibility because Docker can run on any machine seamlessly. Next, we used it to create isolation because no matter what dependencies or installations you have within a container, they will not interfere with any configurations of your local host machine. Another reason is we use Docker containers to provide security because it is really good to have different parts of a larger application in different containers so that when one container goes down or is compromised, the other ones are not affected. Another technology that we used while developing was MinStack. It is really good to use a full standardized stack when developing an application from scratch. And Min stands for, it's an acronym and stands for MongoDB, Express, Angular, and Node.js. MongoDB is a schemaless database. Schemaless means that you don't need to create tables and it sends data in binary JSON format, which makes it easier to send from client to server. Express is a lightweight framework used to build web applications. Angular is a complete framework that is used to create, to rapidly create front-end applications. And Node.js is a server-side JavaScript environment. So let's take a look at our Docker containers that we had in our system. We have 3 of them, and they are, each one of them is a standalone application that can communicate with other containers. And here you can see a Docker file. This is actually where the specifications for each container are defined. And when you start the Docker file, it brings up and builds those containers. Let's take a closer look at the architecture of our application. So we have front end and the back end. On the front end, we have Angular server. Here we use Angular with hypertext markup language, CSS and TypeScript programming language. And this is used to create the front end of our application. Also, Angular server sends all the data to the backend. And the backend has 3 parts to it. It has Express server, database container, and host machine. So when data is sent to backend, it actually is routed by Express server further to the database container or to the host machine. So when, all the user information is saved on the database container. And user code input is sent to the host machine where Maven project is started using the bash and it's compiled and sent back to Express server that sends it further back to the front end. And now let me hand it on to Gia, and she will talk about testing and security.
I have a quick question before you move on from that slide. Can you go back a slide? So the question is, how did y'all like working with Angular, and did you consider using React?
Question. Angular was a lot of fun to work with. In my opinion, it was pretty seamless to be able to add modules and that kind of thing. I considered React, but whenever we took over this project from graduate or PhD student Christopher, he already was starting in Angular, and that's the stack that he kind of chose to use. So it was kind of this is what our client wants, and that's kind of why we continued with it. But React is definitely another really interesting front-end development tool.
We also have some more. So what are some of the limitations of Docker containers compared to other virtualization technologies like virtual machines?
Do you want to take that one, Nasia?
Limitations, I would say, they're actually, there are a lot of benefits to using Docker containers, and you can not only create Docker containers on your host machine, but as we have done it, we've created virtual machine on the cluster, and then on top of that virtual machine, we created Docker containers. One of the limitations I would say, and it's due to the lack of knowledge because we just started working with Docker containers, is figuring out how they are built and how they communicate with each other. And there's a lot more to learn about Docker containers. I've tried working with gRPCs. There was suggestions from our PhD student, and one of the limitations of using gRPCs, that's what you use instead of regular API calls to send data from client to server. And specifically for MinStack, you had to create a proxy, and that proxy, you had to pull an image of the proxy from Docker Hub, and I unfortunately couldn't configure it. It wasn't built properly. So that's some of the limitations for Docker containers.
All right, let me ask you one more, and then I'll wait and let you get a little further into your presentation. So what is it about this project that requires a cluster? This doesn't seem to be that compute intensive.
Okay, that's more for the research that's going to be happening later on. Our project honestly could have been developed on a personal computer, but the reason we chose to do it on the cluster was because when we hand this project off to the actual research that's going to be done, they're going to be setting it up with load balancing, and they're going to be using some, I think there was a little bit of AI that was going to be using with the ASTs to kind of do research on the user's code input and just kind of learn how people are typing code to see kind of what the mistakes they're making and that sort of thing. So it's more for the next step is why it's on the cluster, to be able to handle like multiple users connecting. As it is right now, only one user can compile code on the backend because of the way Maven handles itself. If you were to try and give it like 2 or 3 people accessing the website and they all try to compile code at the same time, only the latest one would happen. It wouldn't actually compile those first few because of Maven's kind of a restricted ability right now. The next step for it would be to put it into its own container, add a 4th container to this system. And then that way you can scale this up or down and add multiple versions of these containers. That way, whenever you have a new person connect, if there's not a container available, it can easily spin up a new one.
All right, thank you. So keep the questions coming, but for right now, I'll let you go ahead and continue, and I'll ask them when you're done with the presentation.
Okay, let me hand it on to Gia.
For testing our web application and compiler, we use 3 tools. First, Apache JMeter is Java open source that allows developers to test functional behavior and performance, such as how the web works against user traffic. Secondly, BlazeMeter is a compatible tool from the first tool. This tool is also used for testing functional behavior of our program. Instead of testing the program manually, users can run a predefined test automatically via the application program interface by making a script with BlazeMeter. Lastly, Maven has a built-in function that users can run a unit test. We use this feature in Maven for testing the compiler. Through these tools, we were able to simulate a scenario that can happen to web applications in the real world and make sure our compiler works properly. For the security, we considered 3 aspects of our program. In JWT authentication, JWT refers JSON web tokens. Angular in our program has JWT authentication. This method ensures that a passed token from front end to the backend is trusted. Then the backend verifies the JWT and accepts access. Next, salt and hash functions are applied to increase the complexity of users' passwords. By adding random values to users' passwords and hashing them together, users can have improved security for their information. Lastly, the program also requests users to register with strong passwords that satisfy the password requirement. As you can see on the right side of the screenshot, the password should be in between 7 and 15 characters with at least one number and one special character. These parts of our program improve the security of sensitive data. Now let me pass the next part to Chris.
All right, so as Justin mentioned earlier, there are 3 main parts of the website that users will interact with. And those are the input window, output window, and visualizer. And before we go on to the demo, I'm gonna give a brief overview of each of those. The input window acts as a code editor for our website. So to do this, we used an open source library called CodeMirror that allows it to do syntax highlighting, line numbering, and automatic tabbing. So it acts like a code editor. Right now it's set to Java, and it can be changed to almost any active coding language. And the style can be adjusted with a single line using a set of presets, or if you want to be more advanced, you can change the way it looks piece by piece. And then next is the output window. The output window functions by sending the text from the input window into a backend container. Maven on the host machine then pulls this text, tries to compile it, and if it succeeds, it sends the output from the executed code back to the front end, where it's displayed here in the output. And the third part is our visualizer. The visualizer is kind of made of 2 unique parts, which is the parser in the back end and the display. The parser analyzes the input code and recognizes the variables and unique things like that and passes them to the display, which you can see on the right. The visualizer currently displays the final states of the variables in the code and includes the information, the scope listed first, then the name, then the value. The parser currently recognizes variable instantiations and can recall existing variables to redefine them. So in the first 2 lines of the main function, you can see that integer I is instantiated but not defined, and on the next line, it's defined, and that's reflected in the visualizer to the right. It currently recognizes strings and ints with a framework set up to make it easy to expand to doubles, floats, and things like that. Integers are represented as purple boxes, and strings are represented as these blue squares. And you'll probably notice that everything in the visualizer fits almost perfectly within its bounds. And this is because the visualizer automatically resizes all of the items within it to make sure that it fits exactly within the smallest possible grid. So for example, there are 4 items in the visualizer here. The smallest grid it can fit into is a 2x2. If there were 5 items, it would have to be a 2x3 grid, and so on. And additionally, the text will shrink to make sure that it stays within the bounds of the items in the visualizer. As you can see in the final item, the function K new scope. And it's enough talking about it. I'm gonna pass it off to Zach, and I'm gonna let him show you some of that.
All right, thanks, Christian. I am going to go ahead and load up a screen share, and I'll show you guys our live version of the website right now. So when the user comes into the website, they're going to land on our homepage here, where they can either create or sign into their account. I'm going to show you guys the account creation right here. And we have, as Gia said earlier, some password requirements as well as other levels of security built into this. So I've already actually created an account with this email. So I'll show you guys me just trying to create an account that already exists. let me type in a password. And it'll tell me that there's a duplicate email in the system, which means that you can't make multiple accounts for the same email, which is a part of security. So I will go ahead and change that to a new one. And I will type in a password that doesn't meet the requirements and try and hit enter. And it'll tell me that it needs to meet our specific password requirements. So I'll go ahead and fill those out now. We'll sign up and it'll tell me save successfully, and where we can come into the front and we can sign into this email. And if I try to sign in here with an email that's already been created, but I type the incorrect password in, it'll tell me that it's the wrong password. So I can go ahead and change that to the correct one, and then I'll sign in. And once you've signed in, you're here on our main page of the website where you see the visualizer, the code input window, our buttons, as well as our output. So I'll start here at the top with this start button. And what this does is it preloads in a skeleton code to the visualizer. And what this does is fills two kind of main purposes. The first being it allows us to preset the naming schemes for the Java code, because Maven requires all of the names and this package to be implemented into the code for it to compile in the backend. And if you try and give it something that's not in that scope, different names, that kind of thing, it won't compile. The second thing that the start button does is it kind of shows you future implementations of this code input window. What it allows you to do is, as we said, this is going to be a teaching platform. So the teachers or whoever is designing modules for the students to learn can actually create skeleton codes or example codes to teach certain aspects of coding. And it can be easily implemented in the backend as an uploaded TXT file, which whenever you hit a button is implemented into the text editor. So I'll go ahead and I will drop a hello code in here so you guys can see this running. We'll hit run. And while it's running, I'll talk about why these buttons are kind of grayed out. So as we said, this is a prototype for the platform. The visualizer is in kind of a very infantile state. It's just kind of the setup. We're expecting to improve upon it, include things like data structures, as well as implement a line-by-line feedback, where the user would be able to click through the code line by line and in real time see what they want or what they've coded. So if I instantiated an I, but I didn't declare it as anything, you'd be able to see it appear that it's in the code, but there's no, it'll be null or whatever. And as you click through, whenever you set that number later on, it would fill in with that information. And so you can see that we've got some output here. And so what I'll do is I'll move on to my second snippet of code, which is a little bit more complicated, and it'll take use of the visualizer and the output window at the same time. So whenever I hit run, you'll see that the visualizer instantly grabbed the code and it's declared these variables based on what we have here. So we have an integer I that we've set to 0, and it's in the scope of main, so we'd see that here. We have the n that's been set to 9, it's also in main. We have a string that's set in here that is also declared in main. And then we also have a separate function that's called function, and it's got its own variable. And so you can see that it's got the name of function there, as well as it's set to new scope. And then the output is set here. So what I can do now is also show you the kind of dynamic sizing of the visualizer by adding a couple of more variables on this. A and B, as well as I'll go ahead and just change this to 1,000, and then I'll hit run. And you can see the visualizer instantly grabbed the new information and showed these new declarations of variables. And then after a couple of seconds, we should see the output update down here as well. Give it a second to can do its compilation in the background. So what's happening here, and the next step for this project, like I said earlier, would be to move this Maven script into a dedicated container that's just waiting for this code to come in, because that way it should be almost as instantaneous as the visualizer is. As it is right now, it's set on a timed loop to wait for code every, I think it's 3 seconds, and then try to output it.
Yeah, event beat twice, so because of that error, it may not get the output.
That is true. Let me try and see. Then we have to wait about 10 seconds. And at this point, this is pretty much everything for our program, so we can open the floor back up to questions with the remaining time we have left. So if there's anything else. And you can see the updated information there as well.
All right, cool. Thank you. Okay, so we have a question. Given that you are running arbitrary code entered by users on your computer infrastructure, what steps do you take to ensure malicious code is properly sandboxed given the limitation of Docker containers?
Yes, so this is the next main step. As it is right now, it's kind of unsecure, in which is it's really bad in the way it's set up. But with our time limitations and COVID, we actually didn't fully get to have the Docker. We started work on it last week, but it just never fully came up. But with pushing Maven into a self-contained Docker container, what it would do is cause, if anybody put any kind of malicious code in, it would hit that container and the container would go down and be able to restart, because Docker containers allow for automatic reboot, and it would keep any kind of malicious attacks contained into a single container, which could easily be spun back up in a matter of 2 or 3 seconds.
All right. How about why did you choose MongoDB? Is your data relational in nature?
We chose it because it's just part of the main stack, and it's what was already kind of given to us by our client. Mm-hmm.
All right. What does your interface provide that other available platforms do not?
Do you want to take that one, Asia?
Our interface. What was the question again? One more time.
So essentially, what's new with your project? What's unique about your project that similar platforms don't support? So what does your interface provide that other platforms don't?
Eventually, this project will answer the requirements set by our client, which is teaching high school students concepts of computer science that are similar to AP requirements.
Most current compilers that are online actually don't allow for user interaction in the way that like a teacher couldn't assign code through the website. It's just like a basic compiler, almost like you'd be running on your own computer. And so our intention was to set up a platform to where Dr. Lori and Christopher could take the base implementation and expand upon it and easily add higher level things like data structures, stacks, queues, all sorts of things like that, and allow it to be done in a way where students can learn more efficiently.
One of the good things about this project is also the visualizer that, from my experience, makes it easier understanding the concepts of computer science. I remember that I've used some other visualizer that was not that colorful, but it helped me very much when I was learning data structures class. When talking about linked lists, especially doubly linked lists, because it is not that easy to kind of imagine how the process is done, but when you see it visually, it helps you realize that, okay, this one points to this node and this one is pointing to another node.
So, going off of that with your visualizations, and also I see that you have visualizations for simple variables and all, and that's fine. But the visualization you have works for variables like that. But if you were to do a linked list or a stack or a queue, do you imagine using a different type of thing, like a canvas tag, like HTML5? Do you imagine using something a little bit more, a WebGL even, to be able to display that? Because as you get more complex data structures, maybe that may not work out as well.
Mm-hmm.
So have you thought about that?
Yeah, Christian, do you want to talk about the Fabric.js that we use for this?
Oh, yeah. So we used a library called Fabric.js to generate the visuals. It's pretty flexible, and we could, when this project is expanded, it would allow for easier visualizations of things like linked lists by creating like a box on the outside with box on the inside, and like layering kind of things like that. It shouldn't be too much of an issue the way it's set up now. It just looks simple in the demo because simple was what we needed for what we have.
All right, thank you. I don't see any more questions. wait a little bit for that. I will say that I had a little bit of flickering going on in my house. So if I just suddenly drop out, I'm just letting you know what happened.
I think the storm passed up here, so hopefully we don't have another power outage like we did yesterday.
Yeah, that would not be the greatest of timing.
Yeah.
Okay, well, it's pretty close to 2, so I'll go ahead and cut things off here. Thank y'all very much
And
for that.
thank you guys for listening. You were a great audience. Thanks for the questions.
Thank you.
All right. Thank you. Bye-bye.
Indeed. Okay, so let's go ahead and have our next team get everything ready. So our next team is Intelligence, spelled in a very interesting way. And their project name is Spotify Song Integration in Games. So I'll go ahead and let them set up for a second, and we'll wait a second for y'all to get started. You can go ahead and share your screen. We just won't get started just yet.
Okay.
Yeah, I'm working on finding everyone to unmute.
I think we're all unmuted.
Yeah,
Okay.
unmuted.
Okay, good.
We go?
Hold on
Well,
one second.
let's wait 1
Oh.
minute.
I want to make sure that we start right on time. Okay, y'all can go ahead and get
Okay.
going.
Thank you, Dr. Cherry. Good afternoon, everybody. A quick word on our team name, since it was mentioned. It's supposed to be like a variable declaration, intelligence, but intelligence also. It's okay. But so, anyways, we are Group Intelligence. My name is Cody Holland.
My name is Ethan Sanford.
My name is Breno Yamada Hikieri.
My name is Atmesh Acharya. Awesome. Okay, so a quick introduction to the project before we do an overview. So the purpose of our project is to showcase the generalized library that we've created that communicates with Spotify's API to make conditional song calls that are played through the browser. When you implement our library, it's a JavaScript library, your users must first log in with their premium Spotify credentials. These get verified through the OAuth 2 protocol. Then designers can play songs that are based on game state or button clicks or any conditional event that is occurring within the browser. These songs are called on the user's behalf. That's a very important distinction to be made because that's how copyright law is, we avoid violating that. These songs are called on the user's behalf. The songs can be any resource in Spotify's extensive library of music. The actions that we support in our library are playing a song from Spotify, skipping to a certain position, volume control, and pausing and resuming songs. So essentially all the functionality you want from a player. I should also mention that I've actually submitted this project for review on Spotify's developer website, and they've given us permission to use this project in a non-commercial setting with commercial usage pending on the completion of the project. So that's our little intro. A quick overview, we're going to talk about the technologies we used, why we used them. I'm going to take you through a little bit of a demo, and then we're going to talk about things like the tools we use, the security, the testing, and working with Unity as well. So I'm going to hand off to Ethan, and he's going to talk about the technologies that we use.
Okay, so on the right, you can see images of all the various technologies that we used. We used Node.js for the main server for our application. This was the intermediary between the web application that we had and Spotify's web API. We had Spotify's web API, which is a RESTful API that basically just communicates with programs and retrieves data that Spotify has on their end and brings it back in a JSON data object. Then, since it is a web application, we had all the regular web technologies that you would expect us to use, such as HTML5, JavaScript, and CSS to make things look pretty and have everything working properly. And for the demo, Cody will get into a little live demo.
Cool. Okay, so for our demo, we have our web application live and hosted on Heroku. So if you want to follow along or you have a premium Spotify account, you can actually visit this URL, or you can do it after in questions time, whatever. But here is the link. We can, maybe one of you guys can post it in chat. But anyways, when you log in or when you visit the website, you're going to want to log in with Spotify. This is required in order to enter the website. So
can you go back to that URL real quick so I can post it in chat?
Yeah. It is Spotify-web-integration .herokuapp.com.
Integration.
Here, I have it copied.
Maybe Ethan can.
Okay, yeah, thank you. Thank you.
Yeah, sorry. Okay, so cool. So you log in, and then it asks for your Spotify credentials. So everybody look away. I'm putting in my password. To allow some permissions. So Intelligence Game, this is our website. The main two permissions that we need are to take control of Spotify on your devices. This is so we can play songs on the user's behalf. And to stream and control Spotify on other devices. These are the main two. We also ask for a couple of things like the type of subscription you have. If you need to have a premium, for instance. Also, I should mention that it's recognized me as Cody Holland since I've logged in. So what I've just went through there, that's the OAuth 2 protocol that Spotify's API recommends that you implement. So, so this is our sort of homepage for the website. For the purposes of this project, we've made 5 little game demonstrations. So my favorite is this one. So I'll click on it and load it up. So it's just a small little asteroid game, nothing crazy. We're not game developers for the purposes of this project. We are showing off the library that we've created. So when I click play, what's going to happen, the music's going to be kind of loud, so I won't talk over it too much. I'll just kind of show the game. It's going to play Thunderstruck. What's going to happen is the website is going to talk to our server, say, hey, we're going to play Thunderstruck. Our server is going to talk to Spotify's web API. The web API is going to go to Spotify's database, and then it's going to travel back down and send it to the client. So I'll click play, and it's going to play Thunderstruck at the chorus.
What you say?
Because you did. The main purpose of what we're getting across should be pretty apparent at this point. The effects that music can have on both the player and the immersion that the player has is pretty immense. When you have songs that players are already familiar with, they already have connotations that are connected with this, you get that emotion and you get that for free. Without having to try to push a new song or to try to push an original song or something that you've created. So we have another demo. It's asteroid themed as well. I guess you guys are kind of getting the genre. This one is to kind of demonstrate the differences between just game sound, which is what you're hearing now, versus when you have music. So if I get 10 little kills, we're going to have a song play as well. So you can imagine games like stealth games that implements 007 music or music from Mission Impossible, which is what that was. Also, really quickly, to kind of show how this is integrated with Spotify, Spotify web player. I'll go to the web player here. This is logged into my Spotify. Mission Impossible here is what we were just playing. And if you look at the very bottom right, it says you're listening on Intelligence Player. So if you visit the website, which we encourage you to do, go to the web player and look how it's integrated, or pull up the Spotify app on your phone. It'll have a pop-up that says, hey, you're listening on Intelligence Player. Um, One last little demo we'll show, and then it's rather slow right now.
We have a question.
This one isn't a game. Oh yeah, go ahead. Yeah.
Did you create these games yourselves?
So this one we did, and this one we did, the snake game. But the other games are pulled from GitHub projects that were public. And it's just to, the purpose of the games isn't to like sell you, oh, go come play our game. It's to show off the generalized library that we've created for other game developers to come in with their games and be able to use Spotify music.
And the other question is, what's the do not click button at the bottom of the page?
Oh, okay. Since you asked. That was the last minute edition.
They asked for it.
But you kind of get, yeah, you did ask for it. You kind of get where we're going with the project. All you have to do is include 2 scripts in any web application, 2 scripts of ours at the bottom, and you can call any song that Spotify has. Also, if I do the record, you're going to hate me, but I'm going to do it again. You can see on the Spotify player, on the Spotify player how it's fully integrated, and it's actually playing it on Spotify. In addition, I don't have to have that up. I don't have to have Spotify open in order to play these songs. Okay, so I was going to show this one, but the demo kind of ran long because of questions and stuff. So I'm going to go ahead and pass it off. There's our little demonstration. We're going to talk a little bit more about the project. So let me go back to the slideshow. Okay, so AJ is going to talk about the kind of the potential and the future of this project. AJ?
I think he's muted.
No,
Can you try to
yeah,
unmute
he's
him?
unmuted.
Yeah, I unmuted him.
All right, cool.
Yeah, you good, AJ?
So talking about the potential of the library that we build, as of right now, we don't have a lot of options for game developers when it comes to the music. Either you can pay for the copyrighted good music, or you can make some music to put on your game. So what we created right now is a generalized library that you can use on other game engines and other gaming platforms, and it's for the future game developers to incorporate in their own game. And as Cody showed you, right now we have just a web-based game, but it can be expanded to other game engines like Unity and Game Maker and other gaming platforms. And talking about the tools and methodologies that we use, it's just like every other team. We had sprints, 2-week sprints with daily stand-ups. We usually did 3 times a week in our regular class times, and we used GitHub for code management and to push anything that was changed in the code, and to track the progress and to see where we are in the project. We use Trello board to see where we are at the project. And Cody's going to talk about the security measures.
Sure. So to just briefly touch on them, we can go into further detail if you want during questionings, but we use the OAuth 2 protocol to authenticate users' Spotify username and password. This is what Spotify recommends on in their documentation. So we went ahead and implemented it like that. To authenticate the application, so like our website, for instance, Spotify-webintegration.herokuapp.com has to be whitelisted by Spotify. We had to like submit a request to get it whitelisted, essentially, to be able to use the API. So our env file is what authenticates the website. It's just an environment variable file. It has a client ID and client secret, and we hash that in the way that Spotify also recommended. So OAuth 2 authenticates the user, and our environment variables authenticate the application. Hope that's clear. And then also, since we use Heroku to deploy the app, we have a secure sockets layer that comes standard. It just adds a little bit of security to the website as far as inputting data like username and password. So I'm going to go ahead and pass it off to Ethan. He's going to say a little bit about
Okay, so whenever we were initially starting out, we initially did user testing to verify that the application was working as expected. So as you can see on the top image, we gathered people that we knew that had premium Spotify accounts, and we asked them to log into the application and see if they could go through the OAuth protocol, the flow to actually authenticate their user and get into the application, as well as play the little demo game that we had whenever we were initially testing the API calls on Spotify's API. As you can see, there were some issues and they were all fixable. So that was the user testing part that we did whenever we were initially getting things going. And then below, like some other teams have mentioned, we used Postman, which is a very good tool for testing and going through APIs, making API calls to them, and making sure that you get the desired output that you want. And we did that to verify that we were, in fact, reaching the right API endpoints and getting the right information. But as well, this opened up a option in the future for another feature of the product. So the whole idea of the product is to have game music provide a certain feeling in the game to add that depth. And what you can do is based on a song or artist URI, which is a uniform resource identifier, you can input those and you can have Spotify generate a playlist of similar songs, which could be really useful in the future for game developers if they wanted to create a whole playlist in a certain theme or mood. And Spotify can do that, and they would have several songs, however many they would want to call from in order to accomplish the feeling that they want and add the depth in whatever space they want. And to move on, Breno will talk about Unity integration and all of the problems with that.
Cool, thank you, Ethan. So by our second to last sprint, we already had the server working. We were already able to do song request calls and just make it work with the browser. So we decided to expand and branch out from web browser games. And we looking at game engines, we decided to try our luck with Unity. We chose Unity because our advisor, Dr. Cherry, he has experience with it, and he also made himself available for any kind of questions we might have. He could help us out to the best of his abilities. And as a matter of fact, not only our group, he helped also another group by inviting us to a Zoom call, doing a little tutorial, going over the flow of how game development works in Unity, some of the scripts, how it works. And the main takeaway from that, the first takeaway I got from that was that the most popular language for Unity, for scripting at least, is C#. And our project's in JavaScript. So does Unity support JavaScript? Yes, but no. So Unity has something that some people call it Unity script, which is a language that has JavaScript syntax, but it's not JavaScript. So you cannot import libraries that JavaScript has, not interoperable. So therefore you can't use Node with it. So at that point we had to focus on C#, maybe try our luck with C#. And we thought about looking at servers that people already had working, people that were able to connect Unity with the Spotify API, with a .NET C#, the framework .NET. And we could either take their code and put into our project, but we didn't want to do that because that's basically the core of our project. We want it to be our own. Or we could do this massive code overhaul or code translation from JavaScript to C#. But at that point, our last sprint was right in front of us. So we decided to drop Unity altogether, unfortunately, and focus on having a potentially shippable product that we have today. So we're very happy to have that product today. We're able to demo it very nicely. And yeah, unfortunately that Unity didn't work, but it doesn't mean that it can't work. In the future, that's the direction that this project would take, not only with Unity, but other game engines like the Unreal Engine. So in conclusion, we, like AJ mentioned, the current system right now we thought about three possibilities that game developers can have for when it comes to soundtracks for their games. They can either pay royalties for music that's already out there. They can use copyright-free music that's usually overused or maybe not up to what you want as a developer, or you can spend a lot of money creating an original soundtrack. Our project introduces another option, which would be passing that cost off to the user. And what's one of the good things about that is that the user might already be paying for that service. Or if the user is not, Spotify offers a 3-month trial, free trial for a premium subscription. And so that's one of the really good things about the project. It's another option, and it's not easy, it's not hard for users at least try. So at this point, we would like to again invite you guys to try it again. That's the link. The link's in chat. If you guys want to try, we would ask you guys to notice there's a feedback button on the navigation bar on the top left of the website. And if you could please, after you try it out, go to that, click that button. It will take you to a Google form. It doesn't take more than 2 minutes to complete. Report any bugs, if you could, please find any, or even give song requests or what kind of game genres you want to see you think that would fit, and even song suggestions. So yes, while you guys try that, hopefully we would like to thank you for listening to us, and we want to welcome any other questions that you guys might have. And if any of the advisory or industry board members want to try it out but don't have a Spotify premium account, we have some throwaway disposable Spotify accounts that we can share our credentials with you guys. So just let us know. We will try to make it work and give you guys the login and password. So yeah, any questions, we'll take them now.
Awesome. Thank you, guys. Okay, so I don't have any questions right now, but I thought of some questions while you're getting your presentation. So I know, like with like with Netflix, after a while, movies gets pulled, TV shows get pulled. Does this happen with Spotify? Do you get like a song on Spotify and then maybe licensing issues or whatever, like that song gets pulled or whatever the case is? If that does happen, how would your API be able to handle that?
Yeah, that's a pretty good question. So the way that our play song function works, we just have a generalized function called play song, and it passes in a parameter, which is a URI, which, as Ethan mentioned, is a uniform resource identifier. So if the URI is invalid, rather than kind of crashing or whatever, we just have, we just catch the error essentially. So if the URI is invalid, meaning the song doesn't exist or is made up or got removed recently, then it just won't play the song. You'll see a little console.log if you inspect and go look at the console. But yeah, we do catch the error so that it doesn't like crash the game or anything.
Would a developer be able to say, okay, well, in case this song doesn't play, do this song, like have a backup song?
Absolutely. Yes, absolutely.
Very nice. Very nice.
Yeah, because the developer is the one that would send the URI to that play song function. So as soon as he sees the error, he can just choose another song if that's the case.
Also, if anyone on the advisory board wants to test out the website, and like Bruno said, doesn't have a Spotify premium, I just posted onto Dr. Cherry 5 accounts, like throwaway accounts that we've that we went through and purchased. So you guys can test out if you want. If you don't have any more questions, a demonstration to me is always more meaningful if I can put my hands on it. So we have a couple accounts if you guys want to test it out.
So while they're playing that, I thought of another question myself and all. So if you were to say monetize this or something like that, or have some way to basically have your project in the hands of developers and monetize it for your benefit, do you see that kind of happening? Is there any avenues where that would be the case, and what would that look like?
So monetization routes is something we've thought about extensively because we're really proud of the project. It's a pretty unique. There's nothing like it on Spotify's developer website, not yet at least. But the routes to monetization are 2 or 3. One is we finally get it deployed on Unity, and we can put it on the Unity Asset Store, where you just include a library in your project, and then your users can log in with Spotify and play the songs. Secondly, we could try to sell the generalized library from the web point of view on web applications. I don't see that one being as successful as Unity. Unity's a pretty standard platform. And then the third one would be like to actually create a game and market it, on Steam or something, game where you can log in with Spotify and listen to Star Wars music, or literally any song that you want, any popular song that Spotify has, obviously. So that would be kind of the routes to monetization that we've talked about for the future.
But the first step would be to go through the Spotify developer page and actually get the license to be able to make it a commercial product.
Yep. Very true.
And what does Spotify, the team behind Spotify, say about this project?
Yeah, so like I said, kind of at the beginning, we have submitted it for review. And what they do is they look over the idea of the project, and then they either give you non-commercial use or not. So we have non-commercial use right now, a license for that. And then they don't give out commercial use of the project until it's completed. So we have submitted for another review, and we're kind of waiting to hear back. So we do need their go-ahead before we can monetize it, which it's possible they don't give it to us, but assuming that all of our security and everything is done properly, and we don't expose the API to anything unnecessary, we're fully expecting a commercial license.
Nice, very nice. So anybody have any questions on here? Okay, I see y'all gonna make me keep asking questions. All right, I see how it is. Okay, no, that's fine. Okay, so let me ask you, can you talk a little bit more about the exact hurdle that you had maybe with Unity? What was the one thing that Unity just doesn't do? And have you looked into other engines that they do that one thing, and if there's promise there with other engines,
Sure. You probably tried to hear me talk. So Bruno, do you want to catch that one?
Yeah, sure. We haven't looked at any other game engines. We spent the entirety of our second to last sprint with Unity. And the problem that I faced, at least, and from all the answers from Stack Overflow and Quora, it's pretty much the problem is being JavaScript. It's not being able to connect to Node.js. That's the problem, not being able to use Node.js. That's the problem that we face. That's the problem that we read. That there was an answer that I read. There was a Unity developer, a professional 7-year experienced Unity developer, that was explaining what Unity script, like I mentioned, was, and how it's not JavaScript, essentially. So, and he literally said explicitly that because it's not JavaScript, it cannot use Node. So that's the big wall that we hit in our second to last sprint, and that's where we started thinking about other possibilities.
Yeah.
Gotcha.
All
right, cool. Thank you.
To piggyback off of that, okay. I was just going to add, to piggyback off of that, the solution to working with Unity is either rewriting our entire code base in C# or using I think it was 2015 version of Unity, which is super old, but using that version of Unity that supports JavaScript natively. So that was moving forward. We're probably looking at, if we want Unity, we need to rewrite our communications with the API into C#.
I think it wasn't even 2015. I think it was 2012, maybe.
Yeah, super old.
We do have a question. Now let me go ahead and get to that. So what any COVID-19 issues and anything that kind of caused problems? Now, can you talk about the issues that you had due to COVID-19?
I think for us,
sure.
Sorry to jump in right away, but I think to us, it
Right,
didn't hit us that hard because our project's pretty much software, so it's very easy to just manage online. Our meetings were, even last quarter when COVID wasn't an issue, our meetings were still mostly over Discord, and now it's just hopped into Zoom. The biggest hurdle, which is not even a hurdle if you think about it, was just recording the presentation every sprint, was meeting up and just meeting up at a certain time. We all work, some of us still work, and just finding that time. That was the biggest hurdle. But as far as the development of the project, I don't think we had as hard of a hit as another group that might depend on more heavily on hardware. So yeah.
Yep.
All right, cool. Okay, let's see if we have any more questions.
Or if you have any more questions.
So do y'all Yeah, I'll ask a quick one because I don't see anymore. So do y'all fully plan on continuing on with this project and also, I mean, that you're dedicated to continue working on this thing?
Yeah, we talked about it a little bit. Most of us are graduating either this quarter or the following quarters, and getting jobs somewhere that'll take up a lot of time. But as far as what we've talked about, we do plan on continuing. We want to get it for Unity working, and we want to maybe market it and potentially make some money.
Indeed. All right, good to hear. Good to hear. All right, cool. Well, thank you guys. Appreciate it.
All right.
Awesome.
Thank you, guys.
Thank you.
Okay, let's go ahead and get the next team setting up. Got about a minute before we get started with that. Go ahead and get your title slide ready and share your screen so you can be ready to go. So let me go ahead and introduce you guys. So about ready to get started. So this is Team Watchman, and their project is an employee location tracking system. And I'll go ahead and let them take it away.
Hey everybody, thanks for tuning in. This is Team Watchman. Yeah, so we did a employee GPS tracking system. I'm going to go ahead and let everybody introduce themselves.
Hi, I'm Andre Caver.
I'm Peyton Sitters.
I'm Tyler Nelson. I'm Wenpon Chu.
And I'm Holland Wolf. Okay, so our main goal here was to create a system employers could utilize to monitor their employees' location while they're working. And so for that, we created an Android app that communicates with our MySQL server that's going to send location data back to the SQL server and then send it to the website. And from there, our goal on the website was that we wanted to create a website that employers could access, and that way they would be able to log in and monitor employees' location. And so now let's move on to the possible applications. And so possible applications for this are the oil industry, transportation services, or delivery services. For example, my father is a sales rep, and when he calls on stores, he has to clock into the store and clock out. Well, when he clocks in, it sends his location data to to a place where his employers or boss could view it and know where they are. Another example is Peyton's brother. He works in the oil field, and when he's on runs on his routes, he's tracked so his employers can keep track and know where he is. This is beneficial for a company in many ways by measuring efficiency of the employees at that time, and also for legal reasons such as they get in an accident or if something else happens. As well, this holds employees accountable for where they are and when they say they're there. And so I'm going to pass it on to Andre now, and he's going to show us a video on the app.
Before we show the video, I want to talk about the app overall. We created the app using something called Xamarin Form, which is basically like an app framework. After a user logs in, it will send location data to a database every 10 seconds. For convenience of the user, we have a break button. So if an employee goes on a lunch break, they can just go on break and it'll stop recording their location, and then they can press the button again to go back to signal they're no longer on break. Another convenience for the user is that we have an automatic logout, which after which the user will set a time, and it will automatically log them out when the time has been reached, because you're usually not going to be on the app when it's time to clock out for work. It'll also display the user's longitude and latitude on the app, so you'll know ahead of time if the app is getting the wrong location data, which sometimes happens when you're because sometimes wireless doesn't get the location data right in apps. Now I'll show you the video because of unforeseen circumstances that happened right before. As you can see, that's the logins page.
Can you go ahead and maximize that? Okay, that's better.
Yeah, that's the login page for our app. As you can see, now, as you can see, there's a go on break button, a log out, and a log out, and right below that is the automatic set logout time. After this, I'm going to press the go on break button. As you see, it will stop sending data, and then press it again and it goes back. Set the timer. And then I'm just about to just straight up log out, since you sometimes will have to you'll probably clock out early on sometimes just for unknown circumstances. And I'm about to pass it off to Tyler. They can show the website side of things.
Okay, so we designed the website so that it automatically fetches the user's location data, the user that's currently logged in, from the MySQL database and displays it in the table with the fields, the username, the ID for the system, and the last location they've recorded. Once it does that, it displays the table entries as pins in the map display. Clicking the table entry brings up that individual's past recorded locations. We have it so that it dynamically updates as the user sends more and more location data, so the table changes and the map display changes as well. We have it doing that at set intervals. In the table itself, you can focus on the pin by clicking the table rows, and in the table, so that you know which pin you're looking at, you can click on it and have it display the information visually. Here I'm going to show off a demo for the website. Maximize. Okay. Here you see the login screen. Putting in the username, the password, sign in. Login failed pop up because I typed in the name wrong. All right, when I click login, it takes me to the main page, shows the employee locations. All right, here you have the user, their ID, and the location they're currently at. You're not going to see the pin moving because we're all stuck at home and nobody can really go anywhere. So you see when I selected the user, it focused the pin in the center of the map. Clicking the user in the table brings up that individual's past employee locations. It shows off the time there, the latitude, longitude, and the date. Order of most recent. And this basically functions the same as the other table. Clicking on the rows focuses the pin on the map, and clicking the pin on the map brings up the employees, the time, the date, and the latitude and longitude at that pin. Okay. Right, click on new employee in case you want to add somebody to the database. You add your first name, your last name, your company name. That makes sure that for what we have so far, make sure that you don't have anybody displaying from any other places. And your password. I don't show it here, but yeah, failed logins bring up a different pop-up. Okay. So here, yeah.
We have a question while you're doing that here. So was there a reason you guys chose to send the location information every 10 seconds as opposed to when the user completes an action such as logging in or adding a record? And does this data only send when the application is actually open and running?
It only sends when the application is open and running. So if the user logs out, they won't appear in this table we have here. And the reason we have it sending every 10 seconds is because, well, this is for developmental purposes. The app, the Google Maps API we're using to display the location data. Sort of what you do is you get a key from them. It's sort of a freemium service. After a certain number of requests, it starts to charge you. You get $200 in free requests each month. After that, each request is, I think, half a cent. And since we're sending so much data, like it depends on the frequency that the data is being received. So for developmental purposes, we were sending it at longer intervals, so we wouldn't stack up a debt. In terms of why we weren't sending information at login and other actions performed, we were mainly focused on getting the actual location data sending working. That certainly would have been a future goal because that's very convenient to have. And hopefully that answers your question fully. I think if I keep playing, I'm going to log out and it'll take me back to the login screen. Okay. The website was designed mainly using React. If we sort of use React because it's, if anybody doesn't know what React is, it's a JavaScript framework developed by Facebook, and they purport it as being a framework that sort of makes it easier to use and develop your AIs. I'm sorry, GUIs. And it adds a lot of functionality for the dynamically changing displays in the table. On top of React, most of the UI was done using the Material UI framework. That's a framework developed to that adds sort of more advanced functionality to make developing GUIs in JavaScript even easier. And we also use the React Bootstrap library. That was for certain things like the pop-up windows, because Material UI didn't really have a good solution for that. And the map display, as I stated before, it's done using the Google Maps API, more specifically their geocoding and their map display APIs. Those are two different things. So if the app sends latitude and longitude data, and what I do on the front end side, the website does, it converts that data using the reverse geocoding API and converts it into a human readable address that's displayed in the table that you saw before. Now, this is just an overview of the features of the app. I'm going to pass it on to Peyton so we can talk about what we were doing on the back end.
All right, thank you. So for the backend, we have a Flask server running on Python 2.7 that handles all of the HTTPS requests from both the app and the website. Both Flask and the Python functions on the server are multi-threaded. So Flask just has a parameter whenever you instantiate the server to make it multi-threaded. And then the Python functions are multi-threaded using a thread pool, because we're going to be receiving so many GPS coordinates from many different phones. That's useful, and because creating threads is extremely what is the word I'm looking for? Expensive with resources. And so the data is stored in MySQL databases, and I'll talk about that a little bit on the next slide. From the Python script, the MySQL databases are accessed using MySQL DB library. There are 3 databases for the user login, the admin login, and then the GPS information. So for example, on the logins, we save the UID, the password, I'll talk about that in a second, not the actual password. The username, the company that they're associated with, so we can use that for filtering later, and then their status of whether they're logged in or not. So upon creation, each user is issued a unique user ID using the UUID module in Python, and all usernames are checked to be unique as well, but we're hoping to use emails so that so they're obviously unique, but it's just as a safeguard. Flask logs the requests that it receives, and then the Python functions have some simple debugging logs as well that are just saved to a text file just in case just for debugging reasons.
Before you move on to that, I do have a question, if that's okay with y'all.
Yeah, go ahead.
Okay, so it is sometimes useful for certain firms to track movements of certain employees, for example, UPS delivery drivers, to provide an ETA for delivering packages to customers. What are your thoughts on monetization for this?
So for monetization would possibly be something like a subscription to a company. To be honest, we hadn't put a lot of thought into the monetization. So it would have to be like on a company level that they would pay a subscription or something of that sort. Is that the only question?
All right, let me go and get one more in there. Any thoughts given to providing deeper analytical functionality, maybe to be able to analyze movements over time?
Yeah, so we'll talk about that in a little bit, but just as an oversight or overview. So for the what we would want to do moving forward, because a lot of applications can just track your GPS location and throw it on a map for the administrators or for your employer. So what we would want to do is to create like work sites, for example, like was mentioned earlier for say the oil industry. If you're going to a work site, there would be some sort of ability to say that their location was in the work site, so that you could do some sort of analysis to see how effective they are at that work site or what type of job it is, and to see who performs better where or something like that. So that would be like moving forward, but I won't talk about that completely right now. But
all right, thank you. Go ahead and continue.
Thank you. So for security, everything is all the communication between the app and the website uses HTTPS requests with a self-signed certificate that was generated using OpenSSL. The passwords are hashed and stored using bcrypt, and that is also how they're checked whenever they log in. There's a function that's built in with bcrypt that automatically checks it. Just so you can see below, that's what's stored in the database, and that's what it looks like. So the salt is stored with the hashed password with the bcrypt format. With the request, there's no raw SQL data returned, just for preventing like SQL injection or to try to glean any information about how it's set up. So you'll receive like an invalid format or just a string of an error if it occurs. You won't receive anything like an actual SQL error. And every request to the server must contain a valid user ID or admin ID. So whenever you log in, you're issued your user ID. And so depending on the request that you're making, you have to have a valid So like if you're sending GPS data, it has to come from a valid user ID that you receive after logging in, or the admin ID whenever you log in there, so that you won't be able to access anything if you're not issued that. And so I'll pass it on to Wenfeng to talk about the future of the project.
Friends, for the future developments, the first thing we want to do is we will make iOS versions so everyone can download on their phone, no matter it's the Android phones or iOS phone. And secondly, we want to use the parameterized SQL. The most important reasons to use this is to avoid SQL injection attacks. So on the other words, if you get the injection attack, the hacker will extract the sensitive information and delete the data. So it's quite important for us to do this. And the next one we want to do is we want to add an emergency button on the app, which can contact authorities. So we can ask help immediately while we have some emergency situations. And then we want to use the TLS for the database connections, which can provide the securities over the networks. And we also do the efficiency analysis for work sites so that we can evaluate the employees. And the last one, we want to add more other necessary and convenience websites functionality to make it more finalized products. And yeah, these are what we will do for the further development. And that is our presentations. Thank you for your listening. And any other questions?
Okay, so we have two different questions, both focusing on the same thing. So, given the fact that you're collecting data such as location data from the people that this is tracking, how do you protect that data? So, in transit, I see you're talking about TSL. How do you protect it in when the data is at rest? And is there any protection right now in transit?
So right now there's that's something that would need to be implemented. So possibly encrypting the database or something of that sort. But right now, no, there's nothing that we have implemented on the database side in case that's accessed.
All right. The other question is, so you're doing Xamarin. I actually had this question too, but when you're doing Xamarin, so Xamarin allows you to have cross-platform, right? But you say that iOS is kind of a future goal. So why choose Xamarin if iOS compatibility wasn't an initial objective?
We originally were gonna do iOS compatibility, but due to the coronavirus kind of messing up, making everyone kind of scattered up, we never really got a good chance to test it on iOS.
All right.
That answer?
Yeah, that's fine. So we have another question. Excellent question. This is very interesting. So a hot topic currently is location tracking to be able to implement contact tracing for COVID-19 exposure. Could your system be modified to provide this functionality?
Could you explain what contact tracing is?
So there we go. So the idea is to kind of figure out from my understanding and figure out who's infected and then like how that can spread and also who they're in contact with. Like Google has had some work in this area to try to use location on your phones to kind of track this. Could your system help out in that area to kind of see where it's spreading, how it's spreading, and just kind of give maybe a heat map, just kind of information to that end? As far as I understand how the contact tracing works.
I think, yeah, it could be modified to implement that. It would take quite a few modifications. First of all, it would have to be on all of the phones that were being monitored and have to be live on there. And then, yeah, they would take some modification of how we process the data afterwards. But yeah, I think, given enough time, that would be a possibility with what we have functioning now.
So to that end, could you tell that, say, 2 employees had been in the same area?
Yeah.
Yeah, I think so. Yeah. Go ahead, Tyler.
Yeah. It shows what times and what dates they've been at certain locations. If 2 employees were in a specific location, you can check and see that they were there at the same location at that time.
So pretty much we would have the data. We would just have to find a way of processing it to, you know, allow us to monitor that.
All right. Now we have, let's see, we have more of a comment. So do either of y'all have a Mac? Because we have a comment that says Xamarin, iOS development on Xamarin requires a Mac. Have y'all looked into that? Do y'all have a Mac? Like one of your team
That
members?
was kind of the problem.
Okay. Fair enough. So I had a question as for me. I noticed on your website, I saw localhost on that. Have you tried to put it on an actual server? Have you done any kind of work in that area?
I was trying to get it on a web server, but in terms of getting all the functionality that we have ready, that was sort of lower on the list of priorities.
Yeah,
All
we've
right.
been kind of plagued with bugs in that sense, and so especially with not being able to get together, it's been super difficult. Because like for the backend, we'll use Postman to test, to isolate it, to make sure that it's functioning correctly, and then if it's functioning correctly, we'll like allow the website to send the request to make sure the website's functioning, and same with the app. And so, you know, one thing after another, debugging over Discord takes time, and it's really a pain. So we didn't get quite as far as we wanted to, but that's the reason.
All right. So we don't have any more questions here, so I'll go ahead and with another one of mine. So you have a phone app and all that works with Android, and I saw you also have the website app. If we focus on the phone app, it's so as far as I understand, the phone app also every 10 seconds is sending your information, right? Does that have to be, does app have to actually be open and active, or just running in the background? Is that good enough? Like if I open the app and then switch to something else, I hit the home button, would it still continue to work?
So it'll run in the background as long as you don't exit the app.
Okay. The other thing is that what would happen if, let's say I disable, so does it use, GPS, or does it use mobile data? Because I can disable mobile data for background apps, like on my phone also. What would happen if I did that? Would it still be able to work? If I turn off location, would it actually pop up with an error message and say, hey, I can't have your location? Is there any way that it would alert the employee that, wait, I can't actually report your location?
I'll let you answer that, Andre.
I believe there is a function that tells the user that you are not locating you, and you have to turn it on. As far as
but does it use GPS or does it use mobile
I
data?
think WinPhone was working on that part when we originally started it. So, do you?
Okay. Okay. Well, we'll just move on from that. We do have feedback. So with the front end in React on the web, it would probably be easier to use React Native as your mobile development library, since the same logic can be reused on both platforms without needing a Mac for the iOS portion. So it's not necessarily a question, just feedback for you there.
Yeah, I have a comment on that. Originally, when we started working on this, I feel like coordinating what tools are being used was an issue for us. That sort of led to problems like compatibility issues down the road. So it definitely would have been more convenient to use React as the app's main framework.
Gotcha. Okay. So I'll go ahead and ask another one of mine. Talk a little bit about your experience with the Map API. I take it that was Google's Map API. So how was it working with that to get that integrated in?
Oh, it was super easy. Like it's really convenient. Um, One thing, they recently changed their pricing model, so that sort of bugged me. And the rest of the people who were working on the website. But in terms of integrating it with uh, the reverse geocoding and displaying it on the screen, that was very simple and very convenient.
Was this y'all's first time using that particular API?
Yes.
Okay, nice. So you were able to learn how that all works. I honestly haven't done it myself, so that's cool. That's awesome. Y'all, got a chance to work with that.
Yeah. It was sort of scary in terms of testing. So if I were to look up online examples, they're what they do is they send a key. They give you a key when you sign up and give them your information, and you use that key to actually make the calls. If you don't use the key, it gives an error when you try to make the call. And when I'm looking at examples, all their keys are expired, so I have to put in mine to they gave us two of them. I put in one of them to see how how they implemented it and how I could like translate that to what I was doing.
Gotcha. Cool. All right. So yeah, that's all the time we got here. So yeah, thank you, guys. Thank you. Okay. So at this point, we'll go ahead and have a 30-minute break. Get up, stretch your legs, grab you a snack, get a little coffee, whatever the case may be, and we shall resume promptly at 3:30. All right, we're about to get started in a couple minutes. Hopefully everybody enjoyed a brief little intermission there, kind of, it says stretch your legs or whatnot. Let's go ahead and get team patent pending situated. So go ahead and unmute your mics and let's get ready to begin.
Hello, hello. All right, mic check. Good. We all good?
Yeah.
Yep.
I guess we're waiting until 3:30 though.
Yeah, let's go ahead and wait. Go ahead and get your slides ready, and you can share your screen and leave it on the title slide.
Sounds good.
Okay, so I know everybody's here and back and ready to go. I know you can't talk, but let's go ahead and hear it for the teams we already had. If you want to do a little clap emoji or whatnot, kind of give them a little.
I'll clap for everyone. It's fine.
There you go. All right, so go ahead and introduce our next team. So this is Team Patent Pending. Their project name is LaTeX Lost and Found. All right, so with that, I'll go ahead and hand it over to them. So let's go ahead and get going.
Okay, good evening, everyone. My name is Christopher Damery.
I'm Nicholas Jones.
I'm Seth Martin.
I'm Caleb Brody.
And I'm Daniel Valcho, and this is our Lost and Found app for the Louisiana Tech campus. It's a cross-platform app for iOS and Android through Xamarin.
Our presentation today will be very technical in nature, and after our presentation, we will have a demo that will explore features from a user experience perspective. We will start out by going through our development stack, and after that, we'll move into our front end for the admin panel and lost and found forms, which we'll see in a minute. Then we'll move on to our back end. We'll move on to a few of our stretch goals that we didn't end up implementing, and we'll finish it up with the Android demo, of course. Throughout our presentation, you'll notice that there are images on the right-hand side of our slides, and these are actually from the iOS application. Our demo will be of the Android application. They are functionally similar, but because of some defaults of the operating systems, they are visually slightly different. Now I'll hand it off to Chris to go over our development stack.
Okay, so for our development stack, Daniel, Nick, and I mainly worked on the front end of the application using tools such as Xamarin and Visual Studio to make a lot of the core features for our front end of the application. Caleb and Seth mostly worked on the back end using things such as Amazon Web Services, Postman, and MySQL to configure the database for what we needed. And for support tools, we used Trello to keep track of ourselves during sprints, and we used GitHub for source control. And now I can hand it off to Nick to start talking about the front end development.
So as for our UI and design, you can see from these screenshots that we tried to go for a clean and professional look. We used a solid gray background on most pages, such as the Contact Us page on the left, so that it wouldn't be distracting. And we used official tech colors, such as the tech blue, on most of the text and the page headers. On the home page, which you don't see here, we have a hamburger menu that we can use to navigate to different parts of the app. You'll see that in a minute. And since we have a shared code base, there are some differences between the iOS and Android platforms. And to implement custom looking things on both platforms, we use what's called custom renderers. And an example of one of those would be loading screens, which look slightly different between Android and iOS. You'll see the Android version in our demo in a few minutes. Next up, I'll talk about the app's front-end functionality. So in this app, you can submit reports for both lost and found items using the page you see on the right. That's a form that provides fields for describing the item along with contact info for whoever submitting the report. Some of those fields that you can see, such as color, type, and location, give you a restricted set of responses you can put in. It makes matching a little bit easier for us. There's also an admin page, which you can see in the center, and from there you can view every lost item report that's been submitted, as well as manually match items. So matching is done automatically on the back end, but it's up to administrators to confirm the match in case they might be incorrect. And once you do that, it will dispatch an email to whoever submitted the lost item report. That page is restricted behind the pin page, which you can see on the left. You have to put in a correct admin pin before you can access the admin page and functionality. So next up, I'll talk about how the front end communicates with the back end. For this, we use the standard C# library to send HTTP requests to our API endpoints. And this is done throughout the app for both fetching and updating lists of items, for verifying that admin pin I mentioned, as well as sending those emails that I mentioned earlier. So now I'll hand it back to Chris so he can talk about the profiling and testing we did for the front end.
Okay, so for testing, Xamarin comes with a really nice UI test framework so you can perform automated testing on your application. So basically what you do is you write a script, and the script, when you run it on your application, it essentially will click all over the app wherever you want it to, basically type into different fields, click on different options and whatnot, just to make sure the functionality is working the way you want it and there are no bugs. For security, we have a PIN code the admin will use to log into their portion of the app. And we use SHA-256 to hash this PIN code so it's more secure on our database. And for profiling, so to run an emulation of Android of the application, you need to have Android Studio. Android Studio comes with a very nice built-in profiler you can run alongside your emulation of an Android app to look at different resource usage. So on the bottom image here, you can see there are 4 fields it keeps track of: CPU, memory, network, and energy. And overall, our application was very lightweight and didn't necessarily use too many resources from these 4 fields. So for instance, the blue line here is memory, and this blue line never goes above 128 megabytes, which, to do the math on it, is about 3 to 5% on average memory on your phone. So overall, very lightweight application and very smooth. So now I'd like to hand it off to Caleb to start talking about the back end of our application.
The back end of our application from the database perspective was written using MySQL 8, and we used the dbeaver development environment to generate this database and all of the tables within it. Here you can see a ER entity relationship diagram of our database that outlines kind of the data flow. I'm going to describe the process of the data flow in our application, just to give some background for it as well. We start in the item table, which is where every item that is sent from the front end is stored, whether or not it is lost or found. Depending on which page of the application you send an item from, it is then tracked in the lost or found tables. The lost and found tables are then used to generate potential matches in the matched items table, which is shown to the admins to confirm and further send emails that were previously mentioned. Once an item is selected as a confirmed match and has been claimed by by the owner of the item. It is then moved to the claimed items table, and all of the records for that item are then cleaned up. We then have a lonely admin table that stores the first name, last name, and hashed PIN of the admins who are able to use our application. Now I'm going to hand off to Seth to talk about our APIs and Amazon Web Services.
Our API was written using Python and AWS Lambda and AWS API Gateway. As you can see here, we have a diagram of how the flow of the API from the front end to the back end works. You can see from the front end, you make a request to one of the 4 endpoints on the API gateway. This can be for lost items, for found items, for matched items, or for admin validation. And each of these request endpoints have a number of REST API methods which are linked to Lambda functions in them. So for instance, if you were to hit the lost items endpoint, you could do so with a GET or a POST request in order to get the data back and see the entire lost items table, or you could add a lost item to the lost items table. And the found items table has the same functionality. For matched items, you can get all of the matched items that the matched item table has calculated. You can update the matched items table, or you can confirm matches on the matched items table. And for admin validation, you can make a POST request to the admin table in the database to check the entered PIN from the PIN page against one of the PINs stored in the database to see if it's correct. And I will hand it briefly back off to Caleb so that he can talk to you about how this interacts with the database we have on the RDS instance.
Our database is hosted in an RDS instance to allow for us to quickly turn on and off the database at a whim. Amazon Web Services is a freemium service, so in order to keep us within the free tier of that service, being able to turn off our database instance and keep our runtimes for the month down was very helpful for us. Having the database in an RDS instance also allowed us to have certain security advantages, which will be further discussed later, but mostly it allowed us to have a secure publicly hosted table that the Lambda functions could communicate with, but that the outside world could not. And now I will hand it back off to Seth for testing security and profiling on our backend.
So we tested the backend API that we designed at 3 levels. The first level was at the Lambda function level, where we could feed test input into the functions to make sure that they were working correctly just as Python code and as functions. On the next level, we could test it within the API gateway to make sure that the connection between the API gateway and the Lambda function was working correctly. And on the highest level, or the most outside level, we deployed the API gateway endpoints and then used the API testing application Postman, which you can see in the top left there, to hit those endpoints with the requests that we had set up with the request methods that we had set up at the API gateway to make sure that the whole pipeline worked correctly. And finally, Chris, during his unit testing that he had set up, also made sure that that tested the full functionality of the app and that the app got back the right data. And so that is a fourth kind of full volume testing that we did. As far as security, you can see in the top right of the slide, that first logo on the left is for AWS Parameter Store, which is what we use to store our database credentials that were accessed by the Lambda functions. And what this did is this stored and encrypted the various database connection functions like username and the database connection string and the password and things like that to make sure that they weren't sitting somewhere in like an environment variable or in the source code where some random web scraper could get a hold of it and then access our database. So what happens now is whenever a Lambda function is initialized, it generates a Bado3 client that makes a connection to the parameter store and gets the credentials from that. And our second main method of security is the icon on the right. That is we put the Lambda functions and the RDS instance on the same virtual private cloud, which is a virtual network that Amazon hosts that allows us to make it so that the Lambda functions and the API gateway and the RDS instance can all talk to each other, but they can only be accessed through the API gateway now from outside applications. So now, since they're all on the virtual private cloud, no other like outside applications. You can't go through Postman and like try to mess with any of the Lambda functions or the RDS instance without going through one of the endpoints set up in the API gateway. And finally, there at the bottom, you see the Amazon X-ray logo, which is what we used in order to profile our Lambda functions to make sure that they were running well and to see if there was anything that we could optimize about them. Basically, how it would work is we would run the Lambda functions, and then X-ray would record in milliseconds how long certain chunks of the code would take to run. So it would record how long it took to initialize, how long it took the handler function to run, and how long the entire thing would take to run. And you could also set up custom endpoints and custom like sections of the code if you wanted to. But basically what we found was that pretty much all of our Lambda functions to run in its entirety on startup would take about 100 milliseconds on the first run. However, on subsequent runs, they would take about 13 to 15 milliseconds. We found that this is because Amazon Lambda, after its first run, will keep a container warm, an instance of all of the connection info and other data generated and kept track of outside of the main handler function of the Lambda, and it'll keep it running in a container for future calls. So on subsequent calls, after it's already been called once, it'll just run that handler function and goes a lot faster since those connections are already made. And it'll keep doing this for about 5 minutes, I believe, as long as calls are continuing to be made, it'll keep it running, and then it'll have like a 5-minute timeout to where it spins the instance down if no more calls are being made. And now that I've discussed with you how we tested, secured, and profiled our application, Caleb is going to talk to you briefly on this slide about an optimization that we did find that we can do thanks to the profiling that we did using AWS X-Ray.
So our original database design did not include the claimed table that I showed in the ER diagram before. We found that in that original design, we ended up having our database tables filling up with duplicate items, because in order to have a matched item, you have to have two similar records existing in the database. We weren't doing any cleanup or any indexing on that database, and through redesigning the database and adding indexes to the database, and as well as optimizing the Lambda functions and adding data cleanups to those Lambda functions, we were able to increase the runtime or decrease the runtime of our Lambda functions after a certain number of items had been processed in our databases. Now I'm going to hand off to Chris, and he's going to briefly touch on a few of our stretch goals that we were not able to implement in this application.
Right, so for our stretch goals, these are basically features for application we weren't able to fully implement due to the time constraints on the quarter, and a little bit to the coronavirus as well. So the first one would be a web portal, essentially the same functionality and features as our application, but you could access it through a web portal such as Chrome or Firefox. We would also like to have had user-specific accounts that you could run through the campus's CWID system. This would allow for more security, I feel, and also more streamlined usability for the users. We also would have liked to have push notifications to show users like when they get an update on, oh, your item has been found, or maybe for the admin to give them updates on a new item has been submitted. And now I'd like to hand it off to Daniel to close this out.
Hey, thanks, Chris. So I'm going to drag our Android emulator onto the screen. We have that running from Visual Studio right now. And as you guys saw, this is our homepage. You saw the iOS version earlier. So here's our Android homepage. Here's our hamburger menu that Nick touched on as well. You can click that and it slides over and shows our options, which is our 4 pages right there. So the first thing that you do, if you see, we have a button on the homepage for report item lost and report item found, the main functionality of our app. So we're going to go in here and we're going to report an item lost. So the first step is you type in your email, and then you can type in an item description. So item description allows for longer inputs. So you can get really specific about your item. Here, I'm going to say I lost a hat, and we have a limited color selection too to help with matching. because, when it goes into the back database, those fields need to be limited so they're able to match together. So we're going to say we lost a red hat and it's clothing type. And we are going to say we lost it in Tolliver. And then on date lost, you can't lose an item in the future. So we restrict that input there. And then I'm going to put in my name. Another cool feature that we have is if you try to submit an item without filling out all the fields, it gives you a notification to let you know to fill out all the fields. So then I'm going to go in, I'm going to add my last name here. And then I can submit this item as lost. And there's our Android loading dialog and item submitted. We can dismiss that and go back to the home page. So then if on another instance, someone else in Tolliver finds a hat, they can come in here and report an item found. So let's say, Nick Jones found the hat sitting in Tolliver and wants to report it. So you can go like nickjones@gmail.com. He found a hat. It was red. It was a clothing item and he lost it in Tolliver. And then date found, and then just type in his name right here. And then we can also submit this item as a found item. There it is. And then from here, this is kind of where the admin area takes over. This is the user facing the student. They report their items here. We have an about page where you can go for more information, and then give you a go dogs at the bottom. There's a contact us page with an admin email and a list of team members based out of Nethkin Hall, room 132. And then we can go to our pin page, which allows access to the admin area. Right now our pin is 1234. And then we can log in here and make a connection. Yep. And then it allows us into the admin area. The admin area gives you a list of all of the items that were reported lost. Here's our hat right here, the red hat. And that's another cool thing. It's one of my favorite features. You can get a list of items here, and then you can click in specifically and see details about that specific item. And then, so that shows you all the lost items, and then we can go to matched items. And then right here, you can click it. Here's Nick Jones, found item, red hat, clothing, Tolliver, and then my lost item that I submitted, Daniel Valgio. And then you can click here and confirm that match when we see that those two are the same. And then the user, there it is, match confirmed, will get an email notification to say to come pick up their item from the help desk. And then we can just navigate back to the home page. And then that's all the features of our app. We showed the lost and found item reporting. We showed the cross-platform functionality with iOS and Android. We showed the email notification system that notifies people when their item is found, the automated matching suggestions from our backend, and then our serverless API. So I really feel like with this app, it could be implemented on college campuses and really help out student life. And no one wants to lose an item and not be able to find it. So I'll move this back across. And if there are any questions, please let us know.
Okay, so I haven't got any questions in the chat just yet, but I'll go ahead some of my own. Okay, so I realize you have where you can detect the location, or where you can enter in the location, so you can say Tolliver, Nethkin, whatever the case is. Have you thought about maybe having it to where they could be more granular, so it can be like, okay, well, I know it's in Tolliver, but I know it's in this area. I know it's in Nethkin in room 240, whatever the case is, right?
Yeah.
Have you thought about doing that, and what changes that would make to maybe matching it and whatnot?
That is something we considered. For the purposes of this demo and this project, we wanted to keep it to general kind of building locations so that we could standardize the input somewhat to make sure that we could have a baseline that we could match against. But were we to continue development on this in the future, I'm certain we could figure out ways to make it work within the API and within the drop-down options to make it more specific locations. And Daniel or Nick may have more detailed ideas on how that would work in terms of like the drop-down options.
Yeah, it would essentially mostly be adding a bunch more options to those lists. I'm not sure if that list dialog has like a drop-down feature, but if it did, we could look into using something like that to implement that.
Yeah, mostly it would be just the process of designing how we wanted to break each of these locations down into their more like granularly specific areas.
All right, so let's go ahead with some more questions. So, let's see, we have one. Would the app have an ability to take pictures of items that are lost or are found in the future?
Yeah, that was also something that we had talked about early on. That was probably one of our stretch goals, even though it wasn't listed. But whenever we came down to it, looked at the functionality of it, we decided not to do that. But that would be a great feature. And if this would go forward, it would probably be one of the first things we tried to implement.
All right, and can you talk a little bit more about what happens when someone claims an item? That's kind of a little fuzzy on how that works.
Yeah, sure. So for when the system detects that there's a potential match, it shows up in that matched items list in the application itself. A admin who works at the help desk, so in the actual lost and found office, would be able to then confirm that match. Once the match has been confirmed, it would send an email out to the uh, person who submitted the lost item request, and they would be notified to come to the help desk and would be provided with the exact room number that the item was currently located in. And from there, after the person goes to the help desk and picks up the item, then um, the item would be considered as claimed already in the database. So once the item has been confirmed as a match, and this is something that we had planned on kind of expanding on but ran out of time for, once the match has been confirmed as a match, it is technically marked as claimed, which isn't the best implementation of it, but due to time constraints, we weren't able to expand on it.
Can you, so we have a few questions on this. Can you talk a little bit more about how a match works? So how do you determine a match, as well as do you do any kind of work in the description area to see if the description of a lost item and the description of a match item, any work in that area to see if those two match up?
So the match comparison process is done as part of a Lambda function in the API. Whenever the matched items table updates, it goes through and checks all of the lost and found items in the database tables. And then right now we have it to where it's checking 3 fields that we standardized. So it's checking the location that it was lost in, the color that it is, and the type of object that it is. And based off of how many of those matched, it serves up those pair of items as a match in the matched items database, so that the admin can look at the matched items table on their page in the app and then review the actual description and the time and date that it was lost at and the people who submitted it and things like that, and then actually confirm that it was a match. We did talk about some process for picking out similar words in a description, or maybe using regular expressions somehow to kind of match the descriptions against each other. But due to time constraints and the kind of the time at which we added in the matched item functionality, we were not able to get to that and decided to go with a simpler kind of standardized match method like that what we're using, and then have the admin confirm it. But where
And
we
that's
can
why
continue
there's
this in the future.
suggestions. They're not confirmed matches, they're suggestions. So there's a user using this, and then they can go in and, if the item descriptions are perfectly matched, but the item might have been moved from the student center to Tolliver, the person can go in and look at the list and find out that that item is the same item.
Yeah. And were we to continue this in the future, we would also add stuff.
Let's move on, because I'm getting more things coming in. So let's move on to another question. So what is the biggest roadblock for achieving your future goals? Like, for example, the photos of items and whatnot. What were some of the roadblocks there?
Mostly time, I would say.
Yeah, time for the most part.
There's definitely some optimizations that we would have to do on the database side and from the Lambda function perspectives before we could implement things like images. And through those optimizations, we could even incorporate the images into our suggested matches. But we would have to actually go through and do those optimizations in the database before we could implement that.
All right. speaking of database things, so someone made a technical suggestion. If you're going to take and save pictures, since this is a serverless approach, an easy way to do this is to take the picture, convert it to a byte array, and then save that as a column in the proper table, right? Yeah. And then that way the byte array can be, rendered using a GET request afterwards. So you wouldn't have to save an actual file, which is, very good suggestion.
Yeah, that's a good idea.
Yes.
So we have one final question. We may have time for another one, but let's go ahead. So is there any process for confirming ownership? So what's to stop me from looking through the found list and just claiming something? I like that.
Yeah, the found list is only available to admins. So a general user couldn't go into the list and find, go shopping basically for different items that are of interest to them and then submit reports for them.
All right. But did you have something else to add to that?
No, I don't think so.
Oh, okay. Just make sure. To that end, that's all the questions currently that I have. So to that end, kind of bouncing off of that, have you thought about having, so right now you have one app that, there's an admin section, you have to know the PIN, right? For extra security, have you thought about making two apps? So you have one that's just a standard user app that's maybe available in the Play Store, and another one that's more of a private .apk that would just be given by the IT department of that university, right?
Yeah, for sure.
I don't think we considered that, but that is a good idea, and it wouldn't be that difficult really, because we could just split the functionality that we have right now.
Yeah, that's something that we could definitely do without too much trouble.
Cool. Now you can still have the PIN just to make absolutely sure, but it'd make it even harder because now you have to get the application and then get the PIN, right? Yeah. If you put it on the App Store, everybody's going to be trying to crack that PIN, right?
Yeah.
So we'd have to add in some more authentication tokens, I think, to make sure it was coming from the right app. But other than that, it wouldn't be too hard to implement at all.
Right, and working on it further, we would also be able to implement an actual login system rather than just the PIN system as well, using the central authentication service at Tech, for example.
Mm-hmm.
Yeah, definitely.
Yeah, and having like a user login would probably help against people trying to claim false items because there's a sort of accountability to it, especially if we would use the campus-wide ID as part of the login.
Indeed. All right. Well, thank you guys. Okay.
Thank you.
Thank y'all.
Yeah, thank you everyone.
All right, cool. Let's go ahead and get our next team set up. So next team the team name is Flex Lasers and their project is Flex Laser, right? So let's go ahead and get them set up.
Everyone should be unmuted already. If not, please let me know. As far as I really can't share my screen, or you view me and my cam because I need it for the project, and it's kind of being occupied. So forgive me for not showing my face at the moment, but I will show it at the end, just so y'all know what I can look like.
Do y'all need me to make another person a co-host, or are you good?
It's fine. We got it planned.
Okay. Okay. Cool. All right. Well, the floor is yours.
Oh, there. Oh, Taylor. For some reason, it won't let me on. Okay, no. There you go. Is everyone unmuted?
Yeah, I'm ready to go. I'm good.
Hello?
Let me go ahead and share our screen.
Can anyone hear me?
Yes. Yes.
Oh, okay. Sorry.
Hold on. How do I can't see the view or to do view.
Do you have two monitors or something? Are you talking about your screen? Because we can see your screen. Well, we see a blank desktop, but
it won't let me go into full screen. Or I double click.
Yeah, it says you're in full screen.
It is?
Yeah, right click, it says it.
You might just go ahead and do it like that.
Okay. Yeah, because it won't let me go in. All right, so I guess Taylor, go ahead and continue.
Okay. Hello, everyone. Today we're here to present our capstone project titled Flex Laser. My name is Taylor Entley, and here's my team to introduce themselves.
I'm Juan.
I'm Richard LaBelle.
I'm Ryan Brown.
And I'm Marcus Garner.
Before we get into the meat of things, here is what we plan to cover today. First, we'll answer the questions of what is the Flex Lasers project and who are the intended users. Then we'll go over some of our lessons learned and future optimizations. Then we shall go into detailed methodologies, tools, and technologies that we used to make our project happen. We'll go over some details we'd like to implement in the future before we go into our product demonstration. So to answer that first question on what is Flex Laser, Flex Laser is a name that we came up when we thought about the core functionality of our application. Flex is shortened from flexible, and lasers, it's obvious, it's the laser pointer you can use to point at a wall or a presentation. Beyond the name, our project is a technology that can be used to enhance presentations to make them more dynamic and involved. How it works is facing a laptop's webcam towards a whiteboard. Our application allows the user to write, draw, or highlight their screen or presentation using a simple laser pointer. This grants the speaker the freedom to move around the room while they present, moving around the classroom or the theater. Of course, this is granted that they aren't standing behind anything that might block the laser pointer.
Sorry.
As for who is our project intended for, when you think about public speakers, a few specific groups come to mind. Educators naturally would benefit from being able to walk around their classroom while being able to modify their presentation as needed, highlighting points as their students ask questions, or being able to put emphasis as it becomes relevant. However, there are plenty of uses of our project outside of the classroom. Public speakers are professionals who are regularly needed to make presentations would be benefited greatly by the new and dynamic way that they could present. Instead of staying almost immobile and rigid behind their laptops or beside their smartboards, they could walk around the auditorium, walk with the audience, or just walk around the stage if that's the environment that they're in. So to answer the question overall, Flex Lasers is intended for anyone who wants to make a dynamic and professional presentation. And now I'm going to be handing it over to Ryan.
So I'll be going over lessons learned and the improvements that we made over the course of our development. We learned that concurrently timings for standard in and standard out need to be tightly considered when running Python scripts simultaneously. That comes to the OpenCV and our project running together. We need them to run together as opposed to one after the other. And we also learned that for our applications to overlay properly, we would also have to consider a screen resolution detection so that everything works smoothly and not a small window and a big screen. The general thing we learned over the development was that working remotely doesn't really, I guess, vibe with us well. We were used to having in-person meetings, and when COVID happened and kind of scattered us, we were trying to use Zoom and all these other things to get it back together, but it didn't have the same kind of flow as just meeting and getting over with it. Now, as for the improvements during the development, we constantly made steady improvements throughout from the beginning and all the way up to the final sprint. And during our final sprint, we made progress to clean up any unnecessary or erroneous files or folders or packages. And now I'll be going over the methodologies and tools used. Mainly, we used Scrum as our development framework because it gave us flexibility around our other classes before we were forced online, and it gave us a good layout of how we would conduct them with our daily stand-ups and such. Our primary means of communication was Discord when we couldn't meet in person because it was just easy to use, simple, and it was there. It should be noted that we did attempt to use Zoom at one point after we were forced into isolation, but we kept running into some technical issues, and the 40-minute time limit just didn't help with our stand-ups. Trello was used to keep us on track and give us a visual representation of our goals and progress, while GitHub was used to consolidate our code and allow for easier collaboration. That's all fine, but we would prefer to meet and collaborate as opposed to having everything online. Now I'll hand it over to Richard for the technology we used.
Yes. Hey guys. There were many available resources for us to choose from when starting the project, so we decided to narrow down our choices based on how familiar the majority of the team was with the technology used, along with the ease of usability and implementation. Our program consists of separate programs that run simultaneously, one for the screen overlay, the other to track the laser use cam. For the screen overlay, we decided to go with an open source framework, Electron, for its ability to allow developers to use web development languages like HTML, CSS, and TypeScript to create cross-platform desktop applications. This made adding objects like buttons, icons, and prompts simpler, as well as positioning them. Deciding to go with this setup for our application made creating quick mockups for our application easy in the early stages of the project. Electron was also one of the first applications we found that gave us a nice transparent window and an option to show no border to allow the user to view their desktop while using the application. We also decided to make use of Angular, an open source web application framework that provided us the ability to easily handle the data coming from the laser tracking program to then convert to input for the overlay program, providing the ability to draw for the user. Angular allowed us to include predefined classes for the elements we were working with to easily manage their position relative to one another, and provided transitions to avoid flashing when prompts appeared and disappearing, as well as when icons would be hovered over. With everyone being computer science students, we felt comfortable using Python for our laser tracking program, since everyone had had some experience with it at some point throughout the computer science curriculum. To actually handle the tracking of the laser, we decided to use a popular Python 2.7 library called SimpleCV. This provided many different libraries for making computer vision programs and had some of the setup completed for developers to pick up from. One important library to note in this allowed us to make use of OpenCV. The logo is shown right below Python. OpenCV is a dense library used to create real-time computer vision programs to track the red laser pointer without having to spend much time learning the ins and outs of OpenCV to do so. For our integration testing, we decided to use Spectron since it was built specifically for Spectron applications. We originally spent about 2 weeks working on trying to implement robot framework into the application, but we struggled to actually work with the code that we had going at the moment. Every time we tried to automate or get the system started automatically, it would crash. So we ended up going Spectron, and Spectron actually allows us to automate steps in the program, completing tasks we often do to test the functionality, and tasks that end users were expected or intended to do to ensure this functionality is working while development continued on. These integrations tests included clicking through all the different icons available on the overlay program, along with navigating the available prompts. Our last few weeks of the project were mainly focused in the two programs together and dealing with bugs that kept around that. So we never really got to manage, or we didn't include integration testing for the Python program in particular, leading up to this day. But we were working on that, and we're planning on wrapping that up in the weeks to come. For NPM, Node Package Manager, that's what we use to ensure everybody's libraries were in sync while developing the project. I don't have an icon up there since we kind of ran out of room, but by making use of NPM, the rest of the team would not only need to run, the rest of the team would only need to run one command, npm install, to include the newest required libraries in the project. NPM also allowed us to create custom commands so we could run both programs simultaneously without having to manually kick off the programs in two separate terminals. These custom commands also allowed us to kick off integration tests to run in order rather than have to manually wait for each test to end to kick off the next. For our profiler testing, in order to analyze the performance of our project, we decided to use Chrome developer tools. Every LLM provides the option to turn on the Chrome developer tools in their applications while they're developing. Using these Chrome dev tools, we were able to watch the performance of the app as we pretended to be a user using the application. One issue we found from the information provided by the dev tools included a performance spike upon clicking on the overlay for the first time, either automatically by the program or through the laser or manually done by the user with the mouse. This is due to the pen drawing function being loaded in the canvas until the user had clicked on the overlay for the first time. To combat this, we decided to make use of Angular's lifecycle hooks, which allowed us to load in a method as soon as the program started to ensure it was not sensing a feeling lag during a overlay. That's all I have for the technologies used for this project. Up next, we have Marcus to discuss future implementations.
Thanks, Richard. Due to our restructuring of our university classes this spring, our last 3 sprints had to be restructured and new team dynamics and communication methods had to be developed. Even with our restructured sprint planning and development changes, some desired features had to be cut due to constraints with in-person testing and access to auditoriums and classrooms. So one of the first tests, or one of the first implementations we would like to do, is track multiple lasers at once. So students sitting in an auditorium could mark something with a second laser that the professor could pass around, and the professor could annotate after the student, clarifying whatever the student had a question about. After that, we would like to implement tracking multiple laser colors. From our search, we found the most popular laser colors were red, green, blue, and we would like to implement these to help create user profiles, which is our next thing we would like to implement. So creating a user profile for a professor within the application would allow them to save their name, preferred highlighting color and preferred utensil, and set a default tracking color for them. So the application would know what color laser is the professor's and which one is the students in the auditorium. And the professor could clear just the students' annotations or clear both of their annotations. And finally, we would like to program buttons using some USB laser pointers or presenter remotes that have multiple functionalities. We would like to implement our clear screen functionality, the take screenshot functionality, and change utensil color and possibly Alt-Tab from the button to change between PowerPoint, Word, or an open tab that the professor may have. And now we'll move to Juan for a visual demonstration of our project.
All right, so let me just get this going. I think I'm going to stop sharing the screen. So are there any questions while I get this started about our application?
I haven't received any.
Okay.
I will say, well, while you're working on that, I didn't hear, I didn't know about the whole different colors for students and props. That's kind of cool. I like that feature. I mean, I know that's future development, but still, I think that feature would be really cool. Now, go ahead.
Well, we thought that just having the option of multiple lasers would be more interactive than just having one color being tracked.
Yeah, no, I like that. That is, I mean, if you give students a laser pointer though and have them draw things on there, that's obviously opening up for certain things, and so inappropriate things. So I mean that's something that you might want to consider. But I like the fact that you say you can clear students independently than the professors.
That's why we wanted to implement the user profile, so the program could identify which laser color specifically is the professor's and which one is specifically a student, so the professor could just immediately clear whatever a student does.
Yeah. So we do have a question coming in, and hopefully this question will be, shed some light on it with your demo, but there's still some confusion over what this project actually does. Now, I realize without the demo, it's kind of hard. So as you're getting the demo prepared, can you explain a little bit more, just an overview of what we're looking at here, or what we will be looking at?
Yeah,
sure.
So you want to go ahead, Marcus?
Yeah, sure. I'll do it while you're setting up. So our project, we would like for a professor or a teacher in a classroom who may not have a smartboard to be able to place their laptop on the podium or center of classroom and use their built-in webcam to be able to track a laser on the whiteboard if they don't have a smartboard, and be able to annotate on a PDF or a Word document that is with our program overlaid on top of it. So they would cut down on costs for schools or businesses to get these really fancy smartboards. And this would allow also easy uploads to Moodle or whatever resource that high schools and colleges use to upload these annotated versions of whatever was in class.
So the main thing here is that it tracks the laser and it will draw on the screen based on the laser, so I can virtually draw on it. That's what, so I want to make sure that that's clear.
Yes, that's exactly what happens. So using a laser, we are able to then draw over any PDF, web doc, or just any image that you want to put up. And we can also take a screenshot so that you can save that and share it with your students later on, or other colleagues. So basically, if this is working, so we are able to move. Can y'all see my screen?
Correct. They can.
Yes. Okay, we are able to move the mouse with the red laser pointer. I'm sorry about the it may be a little choppy. The laser pointer I have isn't the best quality, so it tends to not be detected at all times. So you see, as I move it to the right, the mouse follows.
So do you have webcams to where we can see you physically with the laser?
No.
Juan, hold your hand in front of the.
Yeah, I could. So using the red laser pointer, I
there
can
we go.
Move the mouse. And the whole point of this is just so that the teacher can just walk around and make a word bold or highlighted instead of just having that one little red dot to get the student or other colleagues' attention to that one word or phrase. So, but with that, we can control this. And let me close this window out since it's no longer necessary. And we'll move on to the UI and what each icon can do.
You're going to go over drawing on the screen, right?
Yeah, we will also draw on the screen as well.
Okay, cool. Just make sure.
It's just this.
The webcam got knocked off center when you put your hand in front of it. There it goes.
Yeah, all the borders up at the top can cause a lot of noise for the laser pointer, so you may see it jumping around even more if the top of the webcam is visible to the background.
We wanted to try to get a classroom environment, but due to me being just in my room, it's kind of a little bit of a hassle. So it may not track as is intended. If anything, we can just go straight to a video. We did have a video recorded just in case this it was not cooperating, and I think we might go ahead and do that. Yeah, it's not cooperating right now. So we'll just go ahead and launch that video, and it demonstrates each icon and the drawing function as well. So let me just go there, see.
So while you get that video up and going, we do have another question come in. How long were your stand-up meetings typically?
Stand-up meetings, I think, were between half an hour to an hour.
We would start off with our basic stand-ups, and then we would run right into our meeting. So it was a stand-up / meeting.
And sometimes they would become pair programming sessions as well. If one of us displayed a problem, we would kind of just jump into it versus waiting and trying to meet up again later.
Make sure when you play the video to full screen for the audience.
Okay. So here I'm just demonstrating that we are able to move the mouse with the laser. And if you look at the Python window, you should see that there's a green circle surrounding the red laser dot. So once we demonstrate that, we close that window out, and we then move to each icon. So we have a couple of icons. One icon allows us to draw, so we can turn on and off the drawing functionality so it doesn't get in the way. We then have a icon which allows us to switch our writing utensil. So currently it's just set to a pen. We also have a highlighter. Future goals are to integrate more writing utensils so it's more diverse. We also have a camera function so that we can take a screenshot of the current image or current screen with any drawing attached to it. And we also have our last two icons are user settings, which we were not able to get to, but the user settings would allow the user to set any preferences, whether they want the highlighter selected by default when they start the application, or if they want a different color selected. Our last icon is the exit icon, which allows us to leave our application and just have it close out. But you'll see that we have multiple colors available, and we have just the pen and the highlighter selected. The next, or the one I skipped, was the screen icon. So we can have multiple display types. Right now we just have a chalkboard and a static screen. The static screen allows us to show, like I said before, any web pages, PDFs, images, or anything else that we want to draw on. And the chalkboard just allows us to have a black background, just in case we just want to write any notes without having to display any PDF or web page. And we also have a clear button, which allows us to get rid of any drawings that we previously had before and that we want to get rid of. So, okay. Yeah, and here I just talk about the last two icons, or I take an image and you'll see a notification pop up with a custom name, which is flex lasers attached with a date and seconds. So that way, if we take multiple images at a time, it won't overwrite a previous image. It's all a unique title. And soon I will start drawing. There we go. Yeah, we kind of had an issue near the end where it was just kind of detecting a little too much. But here you see me start drawing. I go down to the button, it activates the data points from the camera start coming over, and I'm able to draw using the mouse. So also with my current setup, having any window open right now is not the most ideal. It just sees noise. So I would prefer to have been in a class to test this, but since I'm just in my room with a somewhat similar whiteboard, but not quite, it gave us a bunch of noise. So we weren't able to test it properly.
So at this point, you're controlling it with the laser pointer?
Yes, sir. We are controlling it with the laser pointer.
Everything in this video has been with the laser pointer.
Okay, good.
Everything, all the icons are on hover. So when the laser pointer is detected on the bottom menu for, I believe it is 3 to 5 seconds, it'll activate that icon or change your programs at the bottom, just depending on where the laser is on the screen.
All right, we have some more questions coming in. What are y'all almost done with the presentation?
Yeah, that's the end.
Okay, cool.
Yes, questions are next.
I just want to make sure we can get these in. So what were the main technical challenges for this project?
Some of the ones I saw was integrating the dot tracker. Early on, we found out that since we're using Python 2.7 and it's kind of coming to a close, it was kind of hard to find a way to run it. So we had to delete Python 3.8 because we found that was a hassle. It was kind of taking priority over Python 2.7. So that's with the dot tracker. Other than that, there really wasn't too much of a hassle from the front end development as well as integrating them. We did find that using Electron and Angular kind of like they were at the same time, there was a bit of an issue, but that was overcome pretty easily with a couple of statements that we found online.
All right. How hard is it to control the laser pointer from across the room? It seems like the fine control would be hard to do.
Honestly, it's not that difficult. At first, when you're getting used to it, it is a little difficult. But when you're in a classroom, the icons are a lot bigger, so you'll be there and you will. It's not as difficult as it seems. Because right now I'm only my projector to the screen is only like 2 feet apart, so the buttons are a little tiny for me. So that's why it seems like it's quite hard to control.
And there's noise that you typically wouldn't find in a classroom because a classroom would typically be a really big whiteboard on a wall versus a piece of poster board with the noise behind it that caused the laser to become a bit haywire.
All right, and for the Python 3 taking priority issue when running, why didn't you just use a virtual environment that's using Python 2?
We came into issues using Python 3 with our computer vision libraries. A lot of the computer vision libraries that we found that we were able to use were Python 2.7 based. A lot of them have not been updated for Python 3 yet.
So was your core code base in Python 3 and then you had to kind of change it, or were you using Python 2 to begin with?
It was Python 2 to begin with. We wanted to avoid trying to set up the camera and webcam through the virtual machine. We thought it would be a lot easier to just try and go ahead and get it working, especially with Electron cross-platform. So our goal was to try and get it on every platform that we had in the team, and rather than all getting the same virtual machine and getting it working on that.
All right. Not seeing any more questions coming in here. So let's see. So with regards to this and all, do you see this being used more by professors, more by maybe professional conferences and all, or where do you see this being having the most use for it? And also, so talking with with other projects with monetization, this, let's say you were to actually monetize this, how do you see that approach going?
I see this definitely being used more in an education sense, more than a business sense. I think this could definitely help schools who don't have funding for smart boards and just have a chalkboard or a whiteboard, but do have the funds to get a projector or a basic laptop with a built-in webcam. And this could quickly change classroom dynamics if they don't have a smart board. And for the monetization question, I think that's the specific audience we would target would be trying to get this application launched and then propose it to education resources like Blackboard and other services to include this.
All right. Any other questions? Okay. All right. So what let's see. So were all the core features that you wanted to get implemented, was that implemented in here, or were there some core features that weren't implemented? And if so, what was the main struggles with that, if that was the case?
I think one of the core features that we wanted to get implemented was the profile settings, but due to us having issues, so we all had different kind of errors with the simple CV, and we got them figured out. But at the beginning, it was a bunch of errors, and that kind of set us back a little bit. So we weren't able to get the profile settings complete.
That and development for the laser tracker, it was, well, that's priority. The main priority is being able to draw with the laser pointer. And due to the limited testing environments that we had and none of them being optimal, we had to put more focus towards that near the end, near the end.
All right, cool. All right, well, thank you. Thank you very much.
Thank you.
Thank you, guys.
Thank you.
Thank you.
Thank you.
Okay, let's go ahead and get our next team, which will be our final team of the evening. This is Team Knoll with the project You Betcha College Football User Variable Model. So go ahead and get everything set up. All right, give 1 second. We'll begin very shortly. All right, the floor is yours.
Hello, we are Team Knoll. My name is Lane Arnold.
I'm Zachary Bigmont.
And I'm Andrew Ohmand.
I'm Travis Freeze.
And I'm Matthew Torres.
And we are presenting our product today, You Betcha, which is a college football betting model. So for the outline for today, we're going to start with the introduction, introduce our tools and suites that we used, go to the features of our sites, discuss all the mathematics behind our model, discuss the testing and further troubleshooting that we did, and then the demo. So we wanted to create a betting model website that housed modern features such as good security, modern website rendering, etc., that resulted in an accurate model, yet was flexible enough to have user input to the model. And this is very unique. There are a lot of college football betting model websites out there, but very few of them have any level of input that the user can do to change the outcome of the model, and none have gone to the extent that we have. So that's what we wanted to set out and do for this project. Our target demographics are college football fans that already gamble, so this is an additional tool for them to be more confident in their bets. And it is a very large market with over $100 billion spent on offshore on American football betting each year. For our development framework, we did Scrum. We held stand-ups daily via Discord, and it took about 5 to 10 minutes a day. And the actual sprints themselves last about 2 weeks. We also use an additional tool to plan out the work for the week using Trello, and our source control was GitHub, which is an online repository. Our stack ended up being the CERN stack, which is MySQL, Express.js, React, and Node. This is not what we actually started off with. We started off with the mean stack, which is a traditional JavaScript stack. When we started off, though, none of us have ever worked with JavaScript. So we were really going into unfamiliar waters. So we decided to change our database from MongoDB to MySQL because all of us is taking a database class here at Louisiana Tech, and we were all very familiar with MySQL. In the middle of our project, we changed from Angular to React because with Angular, we feel like things were developing really slow, and it was always a struggle. And once we switched to React, our front-end development really took off to the pace that we wanted to. So MySQL is our database, Express.js is for all of our API endpoints, React is our JavaScript library for our front end, and Node.js is our backend things that we need running, such as the model itself and some of our security features. As far as some of the extra technologies that we use Postman, used to test all of our API endpoints, both during design and testing itself. We use the Visual Studio Python profiler, used to check the efficiency of the model during creations and various calculations, also to detect memory leaks. We also did Google Chrome and Firefox DevTools just to debug our front end. And we also had access to Tech Explorer, as when we discuss our model later in the presentation, it is extremely computational heavy. So using the server cluster over at Tech Explorer helped out greatly. And so now I'm going to pass the presentation off to Matthew to discuss our features.
Thanks, Lane. So now we'd like to take you through the features that our project provides to our users. And we're going to go ahead and start off with security, because security is probably the most important thing that users seek. So we have password hashing in place for our users. And basically what that means is that we don't store any of the users' passwords in our database as plain text, so that neither we nor anybody else for that matter can read it straight up. So when a user is ready to log in, we just compare the password that they've entered in to the hash password that's in our database in order to either grant them or deny them access to the account they're currently trying to log into. We also have mega tokens in place. And what these mega tokens are is they're custom 1024 character length encrypted session tokens that are based off of a randomly generated key that refreshes every 2 hours along with the tokens themselves. These tokens are individually specific, and what that means is that we can use that to verify our users and their IP addresses. And so now we can talk about our front end, and our front end not only provides us with a custom navigation sidebar on the left-hand side of the website, but it also has an image carousel with live game ticker. And what that means is that our users won't have to navigate away from our website when they're trying to check the football game scores that they're currently trying to bet on as well. We also have links to our social media, as well as other ways to contact us on our front end, which includes our own in-house support ticket messenger. We want to be as readily available as possible to our users, or at least seem as readily available as possible to our users. So, moving on, in order to monetize our project, we went ahead and integrated our front end with PayPal in order to charge the users that want to use our more exclusive features that we have to offer. So our basic users is the first level. They won't have to pay any money at all. But advanced users, they will have to pay $5 a week or $36 per football season, while pro users will have to pay $15 a week or $108 per season. And so with monetization, that'll lead us into the various user levels that we have to offer, which, as I mentioned before, we have to begin with our basic level, which is free to the public and comes with free access to our model's predictions for the games that are occurring that week, while the advanced and pro user levels give users more of an opportunity to see the outcome of a specific game by way of paid subscriptions, like I mentioned before. So pro and advanced users can choose certain statistics that they think that a game will rely on, and these statistics will be sent to our model in order to create a more custom outcome for our users. And with that, I'm going to go ahead and pass this on to Zach to further elaborate on our model and its functions.
Thank you, Matt. As he said, this next part of the presentation will show the process of the model and what went into it. So to start with, we use the cross-industry standard for data mining because that's what we're most comfortable with. It also gives us clear steps of what to do, even if we were to put a few items together. So starting with data understanding and business understanding, we reached out to Josh Plate, a sports media figure of 247sports.com. He then had us contact College Football Unlimited. And through our conversations with them, we realized that we did not want to do player versus player simulations because that does not give a good representation of a team. So now that we had somewhat of an idea of the task ahead, we needed a plan. And for that plan, we used a paper by Stephen Baraz of the University of New Hampshire. We did this because of the time constraints on our projects. This definitely accelerated our plans to be able to implement a model. So now that we had a plan and maybe a possible way to implement our model, we needed the data. From the paper, we knew what type of data we needed. We needed raw statistical data from each team. So that's where College Football Analytics comes in. They were able to give us, going back 13 years of data for each team. But there is a problem. The problem comes in that we no longer have game-by-game statistics like they did in the paper. We only had end-of-the-year statistics. So we had to change our model to fit our needs. And now I'm going to pass it off to Drew to talk about the data preparation process.
And taking this data into context and all, we actually had to narrow it down quite substantially and all because the resources that we had. We initially had 91 features on a per team basis, and we ended up reducing that down to about 40 features and all. The methods that we used whenever we first try to select and reduce our data were backwards elimination, correlation matrix, and recursive feature elimination. We ended up deciding to go with correlation matrix mainly because it had the highest accuracy along with the most amount of features that it could handle. If you looked at the figure on the right, this is just the correlation matrix for the year 2005. And this is every attribute if we were to include it all and correlated to each other. And so since our resources were limited, even though we had the cluster, this would lead to our calculations and our piece of the model taking a few extra seconds and possibly creating impatience for the customer. Moving on.
If I could stop you right there, we have a question. Before we get too far away from this slide, we have a question on security. So with 128-bit sessions token being more than adequate, what was the inspiration and reason for using 1024-bit? Did you run into any speed or storage issues?
We ran into no speed or storage issues. The main reason behind that is we kind of looked at Facebook's authentication tokens as kind of a benchmark, and theirs was 255 links. So we really just kind of wanted to go above and beyond and see, and we did 1024, and it worked fine, and we never had any speed or storage issues. Mainly because our security stuff is running on the cluster, so it ran very fast and was able to do it very fast.
All right, thank you.
Okay. And moving on, our actual data preparation process. There was a wide variation in each feature for each team within the whole football conference, every football conference. If you look at the figure on the right, this is from 2018, just 2 features for all the teams and all. And even with just 2 features, you can clearly see that each one of these dots is a team, the variance in the data is quite substantial. And so if you factor that into the fact that we had 91 features, you could definitely see where this could be a problem. And so because of this, we had to make a different model for each team, even within each conference. And from here, I'll pass it on to back on to Travis.
Thank you, Drew. I'm going to talk about logistic regression modeling. It's a popular technique for modeling a relationship between a number of independent variables and a dichotomous or dependent variable. And we decided logistic regression modeling would be the best for our project since sports games outcomes are denoted by a win-loss or a binary output. So we use logistic regression modeling to determine the weights for our model. And to talk about the equation that we have, we wanted to define a metric for the comparison of two teams. So if you see the probability of team A winning is 1 over 1 plus e to the negative u, where u is defined as beta 0 plus beta 1 x1 plus beta 2 x2, so on and so forth, where x is the difference between team A and team B's performance of a specific statistic, and beta is the calculated weight from the logistic regression. As you can see in the graph below, our probability function is bound between 0 and 1 for its range, which is perfect for a probability function. So now that we've talked about the model, I'd like to talk about the testing that we did. One of the main technologies we used was Postman, and that was discussed earlier as it helped us develop our API by testing endpoints, whether manually or automatically. Other types of testing we did were user testing, which was mainly beta testing with friends and family of members of our team. And that exposed some issues where we wanted to redesign the page layout, and we wanted to make the model calculate faster, and we were able to achieve those things by putting everything on the cluster. We also did unit testing, where we tested our Python programs before implementing them into our final product. And we also wanted to test React and our front end before implementing it into our product. Finally, we did stress testing, which revealed to us that there was a problem is if you had multiple users trying to perform the same task simultaneously on the website, and we were able to get that result. So I'm going to pass it on to Drew so you can talk about our profiler usage.
Alongside our testing and all, we used several profilers to actually figure out which parts of our programs were causing the most strain on our system. We used Visual Studio's Python profiler to measure each program within our model to make sure that we were receiving the optimum usage of our time and all, and that the parts that we wrote weren't taking too much time. Then we went on to test our front end with the developer tools with Google Chrome and or Mozilla Firefox, just to see the timings, check for memory leaks, and the whatnot. Our observations from this, we found that the models before we used this were quite CPU intensive, which we discussed and worked on. And then we also realized that there were no leaks in communication between our front end and our back end. And moving on, we made some social media platforms so that we could reach out to our customers if they had issues or if they just wanted to sit there and talk, ask more questions about our site. And moving on even further, this is our working website right here. The link right here is to our actual website. You can go and test on this anytime you want. We will be leaving it running for the next several days. And right below that is a picture of our homepage on our website. And going on from there, I'll pass this on to Lane for the demo of our program.
Are there any questions while we transition?
I haven't got any.
Okay.
All right, so I want to show all the features that our website has. So this is our homepage. It's very basic and very typical of any website homepage. We have our top 3 games for the week. We have our mission statement. We have each things for our staff and a blurb about each of them. We have explains the navigation of our website, because we wanted, instead of just a typical top bar, we wanted to do pictures, be a little unique, a little bit different. So that's why we decided to do that. We also talk about straightforward about monetization, security, and how our model works. So going over to subscriptions, again, everything is monetized through PayPal. So with PayPal's API, we can either pay directly through debit or credit card, or you can pay with a PayPal account. And this is directly through them. So we're going to show first our basic model, which is free to the public, where you don't have to pay for it. And so this has basically team A, team B, what our model predicts who is going to win that game, and then our confidence level and a percentage by how that team is going to win. And we have, we scroll all the way to the bottom, all 380 games of the regular season, bowl games, playoffs, and national championship in college football. So now I'm going to go over to our register page and create a brand new account. And to note, currently we have set it to where all new accounts are automatically pro level, so you don't have to pay for it just for demonstration purposes. So I'm going to make a new account. And then success, and then we go over to login. And success, and then that will give us access to the advanced model, which this also lists all 380 games. And so let's pick Alabama versus Duke. Takes a second to load because it is sending all that requests to our backend to get the model. And so this is how our basic model, our advanced model works. Is we have the original game capsule, which is, team A, team B, who we think is going to win, and our confidence level, and then we have the current winning team, the current winning percentage based off of the change that you put. And the way it works is you basically pick for the advanced model, you pick your top 3 variables which you think that game will depend on. To the hardcore college football fan, they would know what most of these means, but for the more casual football fans, we have a variable translation table of all 57 other variables that the teams can have. And so we're going to we'll just pick the bottom 3. We go back up and we see the current winning percentage has changed from 99% from 74 to 74%. And I'll pick 3 different ones. And we can choose it. It changed again down to 34%. This game, we're extremely confident that this team will win. So it's doubtful that you can pick 3 variables to change it from 99% to another team winning. As we'll see when we go over to a pro model, I'll show a team that their percentage is not that confident. And so when you submit changes to the model, it actually go to the other team. So we're going to pick Georgia Southern versus LSU. And these are all of the games. I forgot to mention this. These are all the games for the 2019 to 2020 college football season. And so for this one, with the pro model, you can pick 6 different ones. So if we notice, our models at standard picks that LSU will win by 50%. So we're going to pick the bottom 6. Pick this one, this one. So we submit our changes to our model, which hits our backend, which recalculates the model based off of the variables that we have chosen. And we see up here, it actually no longer thinks that LSU is going to win. It actually thinks Georgia Southern is going to win with the models that we have presented by 10%. And then finally, we have our contact us section, which again, since we've logged in, it's given us access to our in-house direct messenger to support any payment issues or just general suggestions or anything. But if you can't log in or you have issues with that, you can DM us with our social media, either on Twitter or on Facebook, or email us directly at our email. And that is all we have to show for our product. Are there any questions?
So we do have a suggestion. It's good to have a password confirmation on sign up in the event that the user mistypes their initial entry. You would just need to check if they match on submit.
Mm-hmm. That would be very quick. We could honestly do that in an hour. We kind of ran up into the end of our product to where we had 4 out of 5 of our team members working on the model for 5 to 6 weeks. And so we were hyper-focused on getting that done because that's basically the crux of our product. But in the future, we can definitely go back and implement that very quickly.
All right, we have a question. Do you plan on fully launching this at some point?
No, we do not.
Right.
That is for a combination of a number of reasons. Not everyone in our group is big college football fans, so they didn't want to be kind of dragged down with that. But and also it's a question of whose IP it is. I asked around to other graduates and said be very careful with just capstone products because the university could possibly claim that as their IP, and just to tread lightly on that. So we had no intention of continuing this after we presented today.
So it's my understanding, and I could be wrong on this, so it's my understanding that y'all do the project, it's y'all's to do with whatever. Tech doesn't have any claim over that, but you can talk with Dr. Gore just to make absolutely sure about that, but that's my understanding on that one.
Okay.
So I have a question, and this may be because I don't do sports as much, so I may not understand this part, but subscriptions, why are they on a weekly basis as opposed to, say, monthly basis like most subscriptions are in other domains?
So the college football world changes very much from week to week. So that's mostly for people who, like, there could be a weekend to where there's 3 huge games that happen that, like, will determine the playoffs in that week. So instead of forcing a user to pay for an entire month worth of games, they'll just pay for that week. So they can have access to all the games for that week. And it could be like the next 2 or 3 weeks, there's like no interesting or worthwhile games to bet on. So that's the reason why we do it a week-to-week basis rather than a month-to-month basis.
Fair enough. Were you able to get any information on models that other people use, for example, ESPN?
Yes. So when we reached out to Josh Pate at 247sports.com, he reached us out. He referred us to one of their sponsors, which is collegefootballunlimited.com. We had a lengthy discussion with them about where to start off with their model. They told us a little bit, not obviously the insides of how their model worked, but what their model was based on. And so that's where they informed us, not to do player versus player, but to do more team stat versus team stat. So that's kind of where we started this project, is looking at other models. We also took a glance at some of ESPN stuff.
Yes, I was going to mention the ESPN. We also looked into Zeus, which is a EJ Sports betting model, which is the model that most ESPN or even the NFL look to. So we tried to reach out to them, but they never responded.
So a suggestion, if the model takes a while to load the data, look into caching the HTML response for a certain amount of time, like 60 seconds, so it doesn't have to load the endpoint response every time the component mounts.
Okay.
Okay.
All right. No other questions. I'll go ahead and ask one of them all while I'm waiting for other questions. So one of my questions is that, how do you know the confidence of this model? So I see that, you say that, oh, this team will win by 10% and 50% and all, but how do you know, maybe if I'm putting money on that, I kind of want to know, I kind of want the model to tell me what I'm like 90% confident that that's what's going to happen. I kind of want some assurance there, like the model saying, yes, this is what's going to happen. Or, how do I kind of know, how sure the model is in this prediction? Do you have any way of displaying that?
Well, the confidence level that percentage is the confidence level.
Oh, that is okay. Well, when you said it, you had said like they win by. I thought that's what.
Sorry,
my
I must have
understanding
misspoke.
was. Okay. I thought it was kind of give me an idea of, okay, they're going to win and they're really going to like stomp the other team, or so I can kind of. Okay, I got you.
We actually have a write-up in our website that specifically talks about what that percentage means, and I forgot to read it.
Oh, good.
I'm sorry.
Okay, good. Did you try benchmarking your model against what actually happened? So you'd have to go back and get historical data to see what you'd have predicted, but that might be interesting.
Yes, we did. And we realized that our model again, this was the limitation of our data. Since we only had end of the game season, we only had to train our model if it was a good season, not a good game. So it really limited our model of what it could do. So for us, since we only were able to get seasonal data, we set our standards relatively low, about 70% accuracy. for our training data just because of the restrictions of the data we could input into it. And for that, our correlation matrix was hitting about 71% most of the time. And now you may see that with some of these major games. Sorry, I didn't mean to cut you off, Dr. Cherry.
Oh, no, I'll just say nice, but go ahead.
Yeah. And for some of these games, you may see that it's really well off. One of the major ones that we saw was, I believe it was LSU versus Clemson. That game was not the way it was supposed to be, but that was one of the issues with just not having all the team data, because LSU dramatically changed coming into the 2019 season. And since we only had the end of the year statistics, we couldn't see that by the end of the season, at the end of the season 2018, that's when they started getting really good.
So maybe y'all spoke about this, but just to throw this out there, now in case I have a misunderstanding, how do you account for the fact that when you're talking about college football, you're talking about players coming and going very frequently, and so obviously the strength of the team is going to kind of fluctuate because of that. How do y'all account for that?
That's going back to college football analytics. They gave us 13 years to look at so that we were able to look at trend lines of teams. So we went back 13 years worth of data for a team, and that's how we were able to tell if they were going to get better based on player data. Because we wanted to stay away from player versus player, which means we would have to keep track of them. So that's why we went with per year.
Okay, good. Cool. All right. Any other questions? We got time for another question if anybody has one. Hey, I will say I like the amount of detail that y'all researched into doing these models and stuff like that. I mean, AI in general is a very difficult thing, and you know, having this be an application of that, there's a lot of, there's a lot of information, a lot of data, a lot of research in that. So I'm very happy with that. And I like the image with the correlation model. That was really kind of cool to see. Okay. I guess maybe in last few moments y'all can talk about it. I know you said with logistic regression. Now, did you try other forms of regression aside from logistic regression and see if maybe that would perform a little bit better or not?
We looked into doing linear regression, but as Travis said, we wanted a probability between 1 and 0, a team winning yes or no. And linear regression can give you widely different numbers.
Fair enough. All right. Well, thank you, guys.
Thank you.
Thank you.
Thank you.
Okay. So, yeah, so that concludes everything. That was our last team. So, closing remarks. I want to say, first of all, I want to say how extremely pleased and proud I am of all the teams here. I mean, you got to think, with COVID and everything, and these projects were seriously disrupted and things just were not, the normal quarter that we would normally have with this and on. So in spite of all that, I think the teams really pulled through. I saw a lot of great things there. So I'm really, really pleased. I'm pleased with the presentations too. I think there was a lot of time polished on those presentations. I spent a lot of time spent polishing those presentations. Really, really nice. And also, I just want to go ahead and give a virtual round of applause for all the teams. And all. I think that it was really, really nice. All right. Yeah, see, so you can hear the applause. So just standing ovation. There we go. All right. So, but yeah, no, seriously though, very, very good job. Okay. I also want to thank the Industry Advisory Board for being here and the general audience for everybody showing up and all and showing support for these teams and listening to their projects. I have emailed Dr. Gord a list of all the teams, all the team members, and all the emails for those students. So anybody here from various companies, hey, if you like what you see, maybe reach out to these students. If you have opportunities within your company, don't be afraid to go ahead and reach out and, see what you can offer them and maybe ask for some resumes, that kind of thing. I want to make sure that if you see something you like, you have the opportunity to go ahead and see what you can offer these guys. Yeah, so thank everybody for being here. I realize this is very unusual. This is not our normal format, but thank you for working with this format and all, and kind of bearing with this. So yeah, thank everybody for coming, and I will see you all next year.